Hi grade 12s, welcome to my channel, and hopefully you are all in good spirits and in good health. Otherwise you would be struggling to even hear what I have to say. Alright guys, I just downloaded this question paper from essayexampapers.co.za. What is key here is study. Guys, if you don't study, unfortunately, you're not going to get anywhere, all right? So this is the math paper 2 that those who upgraded have written on Monday, was it? Yeah. So I have a very special love for paper 2 because many people felt paper 2 is difficult, but in essence, paper 2 is actually more easy than paper 1, in my opinion. Of course, it depends on how these questions are asked. There's a tendency to ask questions in paper 2 in the higher grade category than it is for the ones in paper 1. But if you think about it, there's more rules, more laws, more theorems and whatever that can be applied in paper 1, which makes it difficult if only we were to make the questions to be of a higher grade nature, versus paper 2 where there's not so many rules to dance around. So it's usually around easy things to remember because we've been working on these geometric figures for as long as we can remember, isn't it? But algebraic issues can hurt if you don't understand the rules. And of course, we will have a look at that paper 1 completely. I did have a copy of it. So yeah, let's get to the instructions. We are told there's 10 questions. Of course, we pretend this is an exam, so we say question 1 is complete with its sum total. Question 2, complete with its sum total. Question 3, complete with its sum total. 4, complete with its sum total. Question 5, complete. 6, complete. 7, complete. 8, complete. 9, not complete. Okay, complete there. Wow, there's no question 10. Yikes. And usually that's where the fun is, in those last 2 questions or so. Come on guys, why do you upload an incomplete question paper? I mean, come on. Just looking at this diagram, seeing these lines the way they look, it looks like one of those old question papers. I suppose this question comes from there. Just looking at the way the lines are drawn, but of course I could be just wrong. Anyway, let's slide back into the instructions. You and I understand that this instruction becomes key. No. This one is key. And this one. Key how? In how we score our maximum marks. Okay? Yes, we still have to adhere to all of these other rules, which you should read with understanding. So let's start with question 1. So guys, my desk and my chair, I tend to move a lot when I'm doing things. So there may be some noise in the background that you may hear. It's basically my table and my chair as I move around. So I'm one of those people who are described as having an increased psychomotor activity. So even when I'm seated, sometimes you find that my foot is tapping on the ground without me noticing it. So some thought I was actually shaking. I used to like to perhaps let my foot stand on the toes. Not necessarily the toes, but the knuckles of the toes. What do you call those? The tarsal joints? Metatarsal joints. Yeah, something like that. So sometimes I used to shake my ankle in a way, so it would feel as if it's painful. Somebody would be like, are you in pain or something? And it's not the case. It's just the increased psychomotor activity. Anyway, we are told an insurance broker signed contracts of 15 people. How many? 15. So this would mean we've got 15 contracts to consider here. The monthly premiums in rands, again, it's very important to know in what unit is this all going to be, okay? Payable on each contract is given below. So 1 was 134 all the way until 1200. So nicely put in ascending order. Usually this data, it's univariate. So x is the variable here. We call it one variable. So this one is much easier. Okay, so question is now we need to calculate the mean of the data. So if you know how to do the calculator work here, guys, we're going to go to mode. Then we choose the stat option. From here, we're going to choose one variable. Okay. From here, a single column table comes up. We fill it in, and then we press the AC button. It literally stores our data. So this is what we're going to do. Let me just do it quickly. So my data is ready for processing, and now how do we process it? We are going to go to the shift button. So the shift button basically unlocks the hidden functions of each button. So this unlocks the statistic function. As you can see on button number 1, right on top it's written stat and something dist, whatever this is, maybe distance or distribution, whatever that is. Then here, once we hit button number 1, we're going to choose the variance, which is VAR, and then here we can get the mean, we can get the standard deviation. That's about what we can get usually. So this is how we're going to do it. So we go shift, stat, we go to variance, then we choose the mean, which is what we want. So 1.1, we get 5. Remember, this is money. So this is 570, comma. Now to 2 decimal places is 27 cents. Okay. So of course, for the calculator work and the correct answer, we get 2 marks, 1.2. We need to write down the standard deviation. Again, we repeat the process, shift, number 1, variance, and then the standard deviation there. So what do we get? Again, this is money, so this is 291, 0, 3 to 2 decimal places, so it's 3 cents. So this one is more just getting it. Okay, easy. 1.3. We are told to calculate how many monthly premiums are within one standard deviation of the mean. Okay, now let's have a look here. What is one standard deviation of the mean? So one standard deviation of mean is such that we have the mean subtract the standard deviation and take the mean and add the standard deviation. Okay, which is going to imply, what is this? 570,27 minus 291,03 is 570,27 plus 291,03, which is going to be equal to this situation. All right, okay, all right, maybe I should not do that and say equal to. Now let's see, 570,27 minus 291,03, it gives us 279,24 is 2570,27 plus 291,03. It gives us 861,3. Okay, so we can say therefore we go and check how do we cut our data. We can cut it here. Anything less than 279 So, which is roughly these ones right here. Everything to the left of that line is out. And then we're going to choose 861 is our upper limit. So anything above 800, which is above this. Wait. 7 is less, so above here is here. And anything else above it is out. So these ones are the ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we can say therefore 10 premiums are within 1 standard deviation of mean. Okay, since we're doing maths here, we can try to incorporate the symbols here. Alright, so this is basically the method and the answer of 10 premiums. Nice. So 1.4, we are asked, or we are told that the insurance company decided to increase the monthly premiums. Okay, first point here is that monthly premiums that were less than 500 increased by 18%, okay? And premiums that were equal to or more than 500, remember this is less, this is equal to, they increased by K%. Okay, now we're told that after the increase, or these increases were applied to the above data, the new mean monthly premium is this value right here. Okay, now we need to find the value of K. Not a difficult question here. This is easy because all we can do is to split our data into two parts, right? We split our data into those less than 500, so these are the ones. And those that are above 500, equal to and more. So our data splits like that. So again, these are questions that are probably higher grade in nature. You may want to answer them, you may not want to answer them, depending on how much time you have on your hands to sort them out. So what I would do, literally, if each one of these increases by 18%, I can easily just add them up first, then increase the sum total by 18% and add it back. So all we know is that, folks, we can just add those values nicely. So this is 134 plus 215 plus 325 plus 326 plus 362 plus 429. So this gives us 1,791. To this we're going to add 18%. 18% is this over 100 of the same value. Depends on how you really want to see this. Plus, now we add all those that are above 500. So this is 515 plus 531 plus 598 plus 610 plus 624 plus 728 plus 923. Please make sure the inputs are good here, guys. It's easy to make a mistake here. Right, plus 1,200. So the key here is that this is tedious work. So I'm getting 6763 plus K over 100 into the same value, 6763. Now all of this is going to be divided by the number of these items. What was the number? 15. So this must give us the value that we were told, 686, 4. So of course here you are at liberty to do it however you see it, but for me, I like to get rid of problems because problems is not something I enjoy. So this is implying that we have, now remember this is over 1, we cross multiply with 15, so we have the right hand side. Let's see, 1791 into 18 over 100. Oops, make sure your calculator by this time is on standard computing mode, otherwise certain notations are going to haunt you. So this is 1791 plus, we've got 18 over 100 into 1791. So the answer I am getting here is 2113,38 plus. Now here, what we can do, we can just divide this 67, don't divide it by 100. So 6763 divided by 100 gives us 67. So we have here 6763 plus, this becomes 67,63k is equal to, this one is going to be 15 times 686,44. Okay, just to make our equation nice and linear, so we can say this also implies that k is going to be, unfortunately here we are forced to drift as much as I hate to, but I have to, so this is going to be 15 into 686,44 minus the sum of these two. So we've got 2113,38 plus 6763. So this becomes 8876,38. Then we will divide the entire thing by 2. Sorry, not 2, but what is this? 67,63. So we will see that our k is going to be, now we've got 15 into 686,44, right, minus 8876,38. Divide this by 67,63. So what I'm getting here, this is essentially 20,999,8. Okay, and it continues, which is approximately 21%. Done. Okay, so this increased by 18. This one, 21, is fair enough. It's not too much. Seeing that those premiums, okay. Yeah, I would accept that answer, guys. But of course, make sure that the calculations, what matters here is making sure that the inputs and the outputs are accurate. Otherwise, this is a simple question when you know what to do. So for me, I would say the entire setup is a mark, knowing that this is calculating the mean again, and perhaps these two little big terms, did I just say little big terms? These two big terms, whatever you want to call them, and of course the answer, guys. And remember, this is a percentage, so we need to show it as such. Great, we understand it now, and we fully appreciate what is cooking. Nice and easy. So that was 4 marks, guys. This was an easy 9 marks. You can really take this down within 10 minutes, honestly speaking, if you are really moving quick. But for me, I need to just demonstrate things and showcase what is necessary to take every question as we go through it. So let's get to question 2. So question 2, we know that it's going to be bivariate data. It's usually the case, which is a grade 12 question. We are told the manager of a supermarket decided to do a survey on the number of items that a customer ordered online and the time in minutes. Again, very important to check the unit of measurement that a packer took to have the order ready for the delivery. The supermarket received 10 online orders. See, very important. How many? 10. On a certain day, the information of these 10 orders is shown. So we can see this is all about 10 orders. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Great. So we'll see that for 10 items, it took about half the number of the items in terms of time. 3, 5. Wow, this one is strange. For just 3 items, we took longer. So what could be the reason? So always think of reasons, because when doing statistics, you come across unexpected findings, especially when everything seems to be trending together. As you can see, more items, rather less time. 29, 14, 7, 17, 6, 9, 6, 12, 8, 18, 11, 15, 10, 19. Can you see we did more items within reasonable time, I would put it. But this one we did less, over an unreasonable time. So what happened? Maybe the system failed us. It showed us the order perhaps a little later than it was put. And so we took less time, but in total we got ready later on. Or was it just a complex order that needed more time to sort up nicely? It doesn't matter, but usually these odd ones out, or should we say outliers, we need to understand how did they come into this picture? What do they mean? Because when we're doing research, remember, we have an intention for sure to demonstrate something. And when everything seems to trend, but something just doesn't, it creates another question mark. Why is it there? What is its significance? Sometimes you do research trying to uncover something or to motivate for something, then something else shows up. But of course, you start to see that, okay, I can accept the results in the majority, but there's this. So what does it mean? And again, it incites yet another look into. And who knows, it just might be the one that answers a big question that we were not probably ready to answer, but we simply bump into that answer. Okay, so just be in the habit of understanding and thinking ahead of the question, because it may be one of the questions that says, what could be the reason for this? So you need to not want to cry. These are things you can think about, because it means your mind must be fresh and stress-free. So try not to be anxious, although it's not possible to have no anxiety at all during the exam. It's part and parcel of life. Whenever faced with a challenge, especially one as life-changing as writing a metric exam, there's no way anxiety is not going to be there. But remember, your preparedness lessens the levels of that anxiety, and it allows you to enjoy even the challenge, because if you get to enjoy the challenge, just know you're going to score a distinction straight up. The people who actually score high marks, like the highest marks, because they know, those people actually enjoy the suffering rather than cry about it. Anyway, we are told to draw the scatter plot on the grid provided. I don't have it, so I might as well just try to prepare my grid by using a template that allows me to do some graphs. Okay, so we are going to, of course, folks, always have a topic for whatever you do. So on the y-axis, it goes up to 12, so I can go in twos, right? 2, 4, 6, 8, 10, 12, yeah. What about the x-axis? Goes up until 20, so I can go in twos as well. 2, 4, 6, 8, 10, 12, 14, 16, 18. Right? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. We need one more. 22. Okay, I don't really need to cut it. With stats, we don't really continue, do we? Yeah, this is 2, 4, 6, 8, 10, 12. Of course, this is the origin, 0. So what do we know? On the x-axis is the number of items ordered. Okay, here we're going to have time in minutes. Okay, nice and easy. The number of items is just, the numerical value, natural numbers, literally. Okay, now we can do the scatter plot. So what do we see there? 10 goes with 5, so 10. 5 is in between, right halfway. So this is just the tedious component of this question, which is boring usually. But hey, get used to doing it and perhaps do it fast. But key here is accuracy. Then 3 went with 5, so 3 is between 2 and 4. So it went with 5, so this is again halfway at least, between 4 and 6. Then 20 with 19, sorry, with 9. 20 is going to be between 8 and 10. Okay, 14 with 7. 14 is between 6 and 8, right halfway there. Okay, and then 17 and 6. 17 is between 18 and what goes with 6. Okay, there we go. 9 goes with 6, so 9 is in between here. Again, we go to 6. All right, 12 with 8. Very easy, this one. And 18 with 11. 10, 11. Okay. 15 with 10. 14, 15 goes with 10. Right on the middle there, okay? And then, what do we have? 19 and 12. 19 goes all the way. Okay, so that's what we have. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I've got 10 scatters there, or scatter points, and it means I did not leave anything out. Of course, if we look here, this looks linear. If we were to draw the best fit or line of what, it would be something like a sewer. So we can see that it's linear. Okay, quite a gentle gradient. Correlation coefficient, not so badly correlated to this line. So this would be perhaps a moderate thingy of some sort. Of course, that's just thinking ahead. First, we get these marks. So 3 marks, maybe for doing the scatter and labeling these, another mark, and whatever for the job. 3 marks, I don't really know how. this is gonna be, but perhaps the accuracy component of it. Now we need to determine the equation of the least squares regression line. Again, we go to mode, then we choose stat, then we're going to choose one, is it a plus bx? So this gives us a two-column table, x and y. We fill it in, and then we press our AC button to store the data. So let me do it quickly. So guys, it's a matter of making sure this is accurately put on the table. Otherwise, everything is very easy. So here we need a, b, and then y cap or accent. It's going to be a plus the b value with the x in there. So let's go shift. All the actions now, we're going to go to shift. Then we unlock the statistic function of button 1. It literally analyzes our data. So we're going to choose here the regression action, and from there we get A, B, R, and we may get the mean in terms of X, the mean in terms of Y. And we can get the standard deviation in terms of X, as well as the standard deviation in terms of Y. So there's a lot we can do there, but we're not going to waste our time with a lot. So shift number 1, I go shift 1, regression, and then I choose A. I'm getting 3, 0 to 2 decimal places is 0.8. And then again shift 1, regression, I want B. B is 0.35 to 2 decimal places. Oops, wrote it in the wrong place. Okay, so this means we've got 3.08 plus 0.35x. Very easy question to answer there. All right, so 2.3. We are told to write down the correlation coefficient, okay? R, again we repeat the process, shift 1, regression, we choose R. So this is 0.74. That's a moderate correlation, moderate positive linear correlation, if you will. Of course, how do we score marks here? That's how we do it, and then we get just 1 mark for that. Okay, 2.4. We are asked to predict how long in minutes it will take a packer to pack the order and have it ready for delivery. The supermarket received an online order for 13 items. First, we look at 13. 13 is within the domain because it's from 3 to 20. So 13 is within. So this is an interpolation. So it should be an accurate prediction. Of course, we're going to use the equation. So this is 3.08 plus 0.35 into 13. This implies that y cap there is, okay, at this stage it's okay to just go back to standard computing mode. So we've got 3.08 plus 0.35 into 13. So this gives us 7.63. Alright, of course, since everything was rounded up, we can round off to the nearest, but we can leave it like this. So we can say, therefore, it took approximately 8 minutes to have the order ready. for delivery. So always try to answer nicely. Do not answer your own way. Of course, you can leave it here and say it took 763. This is being too accurate, but of course we saw that these numbers were rounded up already, so why not do it? It's not a big deal after all. We can stop it here. It's not a big deal. All right, so how do we score marks here? Of course, substitution and the answer. Whether you give it like that or you round it up, it doesn't really matter. 2 marks in the bag. So 2.5 says, explain why the y-intercept of the least squares regression line in 2.2 does not make sense in this context. Now the question is, what is this context? The context is basically time over packing orders. So literally, orders that are being packed is the x variable, while time is the y variable. So the issue is that the y-intercept says it would be the time spent not packing orders, and that's exactly outside the context. So we can say it means, or it represents, time spent not packing orders, which is off context. Right. So basically, that represents the time that whoever is packing spent not doing the packing of the orders. And since we're looking at time related to packing those orders, it's totally off the context. So it wouldn't make sense to worry about it or to focus on it. Although we can look at it a bit if we want, but it doesn't really give us much. So I suppose anything you say makes that mark. So easy 10 marks here, guys, which I suppose these are questions for one to come and relax, although they can be a bit of a challenge for many who don't study. Because someone who studies and practices well, these are not very difficult. Of course, this is a bit of a higher grade question. Why higher grade? Because, guys, here you are allowed to think as opposed to being prompted specifically in a particular direction. Here, we want an answer, but we want you to bring it up. Of course, it doesn't have to be a specific answer, but any answer that would make sense in this regard, we would accept. So this is where we say go to town. Go to town, student. All right, that's it about stats. So now we're going to get into some serious business. Let's go back to our normal template. So this is now question 3. So we are told in the diagram below, triangle SRT, so it's the big triangle, okay, is drawn where R lies on the x-axis. So if it lies on the x-axis, it means we've got some x value, but the y value is 0. So if it lies on the x-axis, it means it's then x-intercept. Please know these things, guys. And S lies on the left of R. So if it lies to the left of R, what does it mean? It means the x-coordinate at S is less than the x-coordinate at R. Again, these are things to know and understand. T lies on the y-axis. So if it lies on the y-axis, what is it? It means we've got 0 and some y value. This means it's a y-intercept of a particular line. And the coordinates of S are this one, so it's also missing something. So this is already suggesting this is a potential question. the equation of RT is like that. So the best way to write it as well is to write it in such a way that we can use it. So y is going to be 2x plus 10. And guess what? The y-intercept of RT is basically the coordinates of t. So we are already given this somewhat. So y there is 10. So we've got all the coordinates. And of course, if this is RT, we can work out the x coordinate here as well. So if we replace this with 0, this becomes minus 5. Okay, so this is called working as fast as possible. Of course, don't be too quick to miss information. Of course, we know the x and the y-axis meet at right angles. So this is 90 degrees. Perhaps this is something we can do. Although it's not necessary, but we can do it. You know, with analytical geometry, this one, we don't have much, so we will have to deal with what we have. So we're already given the equation. We can actually, from the gradient of 2, work out the angle of inclination. Knowing these coordinates and those coordinates, we can actually find the length, okay? That's what we can do. Here, we don't have enough information. So this means we need extra. V, again, we don't have enough information. So V is going to be x is to y, which on its own begs for more information for us to say something there. And yeah, that's about it. So now, what I like to do when I have so many question marks, I often skim and scan the questions and decide which ones I can tackle, which ones I may not want to. So calculate the coordinates of r, we can do it. The length of RT, we can do it, eventually knowing those coordinates. It is also given that 2 times RT squared, which is what we just calculated, is equal to 5 times SR. Then this rule allows us to actually solve for x. So this is the extra information we were looking for. So it means we can handle that. If it is further given that V lies on ST such that VR is perpendicular to ST. So if that's the case, we know this is 90 degrees. Okay. 90 degrees. Or we may want to put it else. I mean, this is 90 degrees. Also, this side is going to be 90 degrees. We can show it double. It's not a big deal. Now, we have enough information as well to work out something related to this, okay? Okay, we need to determine the equation of VR. Okay, that's easy, 5 marks, because we're going to use that perpendicular relationship and a point. Nice. Hence show that the coordinates of VR, okay, this is 2 marks, but why? Is there an easy way? For me, we have the equation of this. We'll literally have the equation of that line, literally from just finding the gradient of VR. Because we've got the same y-intercept and the gradient we will have calculated in the attempt to find the gradient of VR. So wow, this is a higher grade question in just the way it is, but it's actually a simple question if you understand. So okay, fine. This is just to trick us to waste time thinking of an easier technique when it's actually right in front of us. And then R is a reflection, R prime is the reflection of R about this line. So what is this line, guys? This is the y-axis. So if this is the y-axis, therefore it makes it a horizontal reflection. Now a horizontal reflection, it means x is going to be multiplied by 1, minus 1. But the y values don't change because it's a horizontal reflection. So literally, we know that this becomes a plus 5. So what I would do is to do this. Of course, you don't have this luxury now. Me, I'm using the technology. So I'm going to take it to here. And then I'm going to take that. Yeah, I confused the tablet. Now there it is. Of course, this was not necessarily drawn. At the moment, it's more of a construction. So we will say, okay, you've served your purpose. Please leave us alone. So we know that this becomes r prime, where we multiply the x coordinate by -1. So we get 5. The y value remains. Okay. So this is literally setting up our question for answering. And we know here, we need to find the area of this quadrilateral, RVTR, okay? Sorry, is RVTR, okay, R prime, sorry. So not a problem. So we can clearly see we've got this triangle and this triangle. So we will split it into those two triangles and sort it out. Now let's start answering. So we know that these marks are coming home. Calculate the coordinates of r. So we know that r is such that 2x plus 0 plus 10 is equal to 0. This is the x-intercept of RT. All right, great. So this implies that 2x is equal to -10. Therefore, x is -5. Therefore, remember the coordinates of r is going to be -5 and 0. We need to show this in the ordered pair. All right. Great. So substituting a 0 then, knowing it's an x-intercept and solving for x. But these marks are not going to be given in full if this is not written. We need to see this. As much as you're not going to get a mark for it, if this is not represented, you lose 1 mark for this, okay? Be very careful. Simple questions have some very naughty restrictions on how you're going to represent the answer. The question said coordinates. There's only 2 for a point, at least in our knowledge. So we need 2 things together in the ordered pair, okay? Answer the question. Remember, these are clear instructions. They need to be followed over and above the general instructions, okay? 3.2 says calculate the length of RT. First of all, we need to state that T is 0 and 10. Why? This is the y-intercept of RT. Since we were given the equation, it's pretty straightforward. We can say then RT is going to be the square root of x at t minus x at r all squared plus y at t minus y at r all squared, which implies that RT is what we see. The x at t is 0, minus 5 is going to be plus 5, plus y at t, this is 10 minus 0 all squared. Therefore, RT is, this is 5, sorry, 25 plus 100 is 125. 125 is 25 times 5, right? So this is square root of 25 is 5, so this is 5 root 5. Of course, guys, use the calculator here to avoid trouble, but don't starve your brain of the activity, because at some point you will input wrong values onto the calculator and you will get strange answers. If your brain is completely hidden by not being exercised fully, you are in trouble. So first, we get a mark for stating that. Secondly, substituting into the correct formula. And the final answer. Remember, this must be mentioned. If it is not mentioned, this is not the correct answer, okay? You lose a mark. Except if somebody is too friendly, which is not allowed. Remember, this is an exam. It tests more than just knowing how to calculate. Can you be particular? Because when you become a professional, you need to mean what you say. And you need to convince your audience that you understand exactly what you are talking about, or else nobody will take you seriously. 3.3, we're going to use the rule, okay? We know that 2 times RT squared is going to be 5 times SR squared. This is given. So what does this imply? 2 times RT is 5 root 5 squared is going to be equal to 5 into, actually I would prefer this big one, because this is going to be x at S minus x at R all squared plus y at S minus y at R all squared. Okay, distance formula, folks, and be systematic. This is 2 into, this one becomes 125 is equal to 5 into, substitute x at S is m, minus that at R is going to be minus 5, which is plus 5, into y at S is 1, minus that at R, which is 0. This is squared. Alright, so this implies further that this is 250 equals, I'm actually very lazy now to deal with this business right here. Okay, 5. Okay, let's continue with the preaching. Sometimes I've got to show you things. Okay, this one simplifies strictly to 1. Okay, so we divide by 5 throughout. What do we end up with? We end up with m plus 5 all squared plus 1 is equal to, we divide this by 5, we get 50. Now, and then this implies we isolate this square. 50 minus 1, that's 49. Both of these are perfect squares, so we can take the square root. Even if it wasn't, if any one of them that we're interested in is a perfect square, even if this one was not, we will take it. Okay, so this implies that m plus 5 is going to be plus or minus 7. Therefore, m will be, now remember, we need a negative answer, so it must be minus 7 minus 5, which is going to be minus 12. Okay, great stuff. We solved for m. Remember, the instruction said the x coordinate at S must be less than that at R. Minus 12, certainly less than minus 5. Otherwise, if we chose plus 7 here, we would get 2. Now 2 is to the right of this point. It's not to the left. So the examiner here was a bit friendlier. So what can we do, guys? There's substitutions here, a mark, and perhaps the substitutions here is a mark also. 2 marks, right? How many marks are we scoring here? 4, really? 3 marks, of course. We can say here the entire setup would be fine. Maybe here, maybe there, it's not a big deal. Yikes. Interesting times. Whatever. 4 marks in the bag, however it is distributed. So 3.4. We are told that it is further given that V lies on ST, such that VR is perpendicular to ST. We are to find the equation of VR. So this is going to be a bit tedious. The space is not enough. So 3.4. What we have here is that the gradient of VR times the gradient of ST must be giving us minus 1. Of course, given that VR is perpendicular to ST. Nice and easy. So this implies that the gradient of VR into y at t minus y at s over x at t minus x at s should give us -1. So this also implies that mvr into y at t, we spoke about it, it's 10 minus that at s, which is 1, over x at t is 0 minus that at s, we got -12, so it's going to be +12 is equal to -1. Please guys be patient. So mvr into it helps to solve everything, because if we ever need this gradient we must be showing it here. So this is 9 over 12, which is going to be 3 over 4, okay, is equal to -1. Therefore mvr is going to be the negative reciprocal here. Nice and easy. Nice and easy. So we know that this is a negative gradient. We should see it, and it's fairly steep, okay? It's more than 1. Nice. We can say then VR as a line is such that y is equal to -4 over 3 x plus c. Now through point R, which we already have found above, we know that 0 is going to be -4 over 3 into -5 plus c. Therefore our c is, this is going to be plus 20 over 3, transpose, it becomes minus 20 over 3. Of course, this one would cut somewhere there. 20 over 3, let's see, what is that? So it's minus 6,6, which is roughly minus 7. So that's fair enough. So we can conclude that y is equal to minus 4 over 3x minus 20 over 3. Okay, we can accept this answer. It doesn't look too far-fetched. Okay, so 5 marks for this. Obviously, this is a mark. Substituting a point is a mark. Getting the gradient is a mark. Getting the other gradient is a mark. So 1, 2, 3, 4. So essentially, writing up the entire thing, which is the rule. Maybe we can mark it here. Not a big deal. So 5 marks in the bag. Easy stuff. 3.5. We are then asked to show the coordinates of VR. So we know that we now have the equation of this line, and we need the equation of that line to solve simultaneously. But we need to state that ST as a line is such that y is equal to, guess what? There is the gradient of S3, is 3 over 4. X, and the y-intercept is 10, so we're just going to write it like so. So this is the tricky part, which explains why this is 2 marks, because from above we already have enough tools for ST. So all we need to do, we can say now, then V is such that 3 over 4 x plus 10 is equal to literally minus 4 over 3 x minus 20 over 3. Why do we know this? We know that ST is equal to VR. But these are the lines, in terms of the lines, the vectors, not in terms of size. Okay? or we can say it's a point of intersection. Perhaps the best thing to say, yeah, let's leave it at that. Once we show that these are the vectors, I think that's fine. But perhaps it's controversial. You may even want to drop this because it suggests something else. But I think as a vector, it's okay. But if we think of it as a line physically, we might be misleading. So let's drop it before we start causing us problems. This is simultaneous equations. We don't need to justify that. We move that over, it becomes a plus. Then this is going to be over 12. Right, 4 times 3 is going to be 12. Then we cross multiply the 4 by 4, that's 16. 16 plus 9 is 25. So this is what we have of is equal to. Then this is minus 10. 3 times that is going to be minus 30. Minus 30 minus 20, it's minus 50 over 3. Nice. Nice, 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 nice. Therefore, x is, so we literally multiply to this, that coefficient flipped around. So 3 to 12 goes 4 times, right? So we've got 4 there. Then this one goes 2 times. So 2 times 4 is 8. So this is minus 8. Nice and easy. So this is good. Therefore, y, we can just show the substitution. 3 over 4 into minus 8 plus 10. So we know that 4 goes 2 times. That's multiplied by 2. That's minus 6. Minus 6 plus 10 is a 4. So we can say indeed coordinates of v is minus 8 is to 4. So again, why 2 marks here? I have no idea, guys. But for me, this equation is key. Without writing it, I doubt we would know what to do. And perhaps solving simultaneously would be more important. The arithmetic gymnastics, they just uncover, or the algebraic gymnastics, they uncover that minus 8 and this one. But I sometimes have an issue with this one. We substituted something there. But is it strong enough? I guess. This is where the examiners become a little silly, because they leave you to think this thing is just too simple than what you did. But actually, it's where the marks sit that matters here, rather than the method. Of course, if you see something else, sorry, it's up to you. But I am seeing what I see. Sometimes I don't care about what it is supposed to be like. I care about what I can do about it, because that's what matters to me. It's what is going to give me marks. Now, R is the reflection of what. So, if that's the case, we need to state that R prime is going to be 5 and 0. Nice. We need to say it. So the horizontal reflection already tells us that we're going to multiply the x value at R by minus 1, while the y value remains. So we need to state those coordinates. Nice and easy. So we don't need to justify it. Now we need to find the area. So what do we have? So basically we've got these two. This quadrilateral of ours is made up of those two triangles. We can see this one, we just need VR. We've got the coordinates of V. We've got the coordinates of R. So this is minus 8 is to 4. Right, so we've got the coordinates. We can calculate that length and this length. So this triangle gives us a lot of work. This one, we need just R prime, which is going to be 5 minus 5. It's a horizontal line, so it's 10 units. This one, the height is the y-axis themselves up until 10. So that's easy. So what we need here is to find VR. So this is going to be the x at R minus x at V all squared plus y at r minus y at v all squared. Okay, so x at r is minus 5, minus that at v, which minus 8 is going to be plus 8 all squared is 2. Y at r is 0, minus that one at v is 4. So literally this is going to be minus 5 plus 8, that's 3. 3 squared is 9. 16, that's 25. Square root of 25 is 5 units. Okay, again, no need to sweat. We need V also. We want VT or TV. Since we saw that that triangle gives us a lot of work, we might as well do it separately. X at t minus x at v all squared plus y at t minus y at v all squared. Please stay consistent with how you named the first one. Otherwise, if you swap them around, you will get a wrong answer. Okay, substitute. X at t is minus, in fact it's 0, minus 8 is going to be plus 8. Y at t is 10 minus y at v, which is 4. Okay, we square that. So this is 64, this is 6 squared, 36. 64 plus 36 is 100. Square root of 100 is 10 units. Okay, nice and easy. So what do we say now? We will say then area of R V T R prime is going to be area of triangle, say VRT, plus area of triangle, say TRR prime. So this is a triangle, so this is going to be half. The basal side we can say VT times VR plus half. The basal side here is R to R prime times OT. Nice. So this is half. VT is 10, VR is 5, plus this one we need to show the calculation is going to be 5 minus 5 is going to be 5 plus 5 times 10. Okay, easy. This was a calculation. It's too simple. We can show it in the actual calculation. So 2 to 10 goes 5 times. 5 by 5, that's 25. 2 to 10, 5 times. Then 10 by 5, that's 50. 50 plus 25, that's 75 units squared. Very easy calculation. Otherwise, all you needed, always these kinds of questions will always need a split of the quadrilateral into some identifiable structures that we can work with. Now, where are the marks, guys? This is key. That is key. This calculation of R to R prime. We're scoring 5 marks here. Okay, good. And what else? The answer. Provided this is correctly given. If this is not correctly given, the last mark is lost. Okay? So essentially that's it. Well, what we can say, guys, is just perhaps the rule here, or we can say the general substitutions as a whole. You know. Either we give it here as a form of a rule, or there, splitting it into 2, whatever. So we've got 5 marks in the bag. Okay, this one is a bit demanding. this question is a bit demanding in terms of time, so actions that are quick and focused are very important here, rather than to waste a lot of time. Okay, so we're scoring maximum marks here, literally, by just knowing what to do. Okay, now let's get to question 4, the technical grade 12 question. But it always has some easy questions as well. All right, we are told in the diagram M is the center of the circle having this equation. So from the equation, we can write the coordinates of M. It's going to be 3 and 0, because y is just squared. Okay, very important. And the radius here is 5 units. So this is 5 units. This one going up there is 5 units, but because it's not named, we're not going to worry about. But TM is a radius as well, so it should be 5 units. So these are things, guys, to make sure you think about. Of course, this is units. Please, it doesn't stand for anything else. Why do we know this? Is because this line is equal to that line for TM. These are ready. Be very careful. Now, we're told E has those coordinates and T are points on the circle, so these are concyclic points. But now T is nothing but X and 0. Oops, not 0, X and Y. So we don't know the coordinates there. Okay, we will find out. It's a potential question, literally. And EC is a tangent. So if this is a tangent, we know that the tangent is related to the radius perpendicularly at the point of contact. All right, and cuts the x-axis at D. So at D, we know that we have some x value and 0. Okay, because if it cuts the x-axis, it's an x-intercept. So at the x-intercept, the y value is 0, just missing the x value. So ED. Okay, ED. What I like is to just do this sloping thing. ED is basically 15 over 4. So that's just for the length. Sometimes for ratios, I do that. Okay, great. Now, MT produced. So once this is produced, it means it's the same straight line. So there's no angulation after T. Meets the tangent at that point. Again, what do we see on this point? We are missing the P value. So that's a potential question. We need to think about how to find the value of P. Okay, that's about it. So what can we do with this information? Well, what I see is that the radius is 5. This is 15 over 4. And if we look at this triangle right here, it's a right-angled triangle. And in this right-angled triangle, just see it. So if we look at that small little triangle, it's a right-angled triangle. So we can actually find DM, right? Now from DM, we subtract 3 because this is the side that we don't need. We just need that piece. It can give us that x coordinate at at D. So we find DM using Pythagoras here. We then subtract the 3 units. It gives us that. That's what we can do. Because also D, being told to us that it's on the x-axis, it's already suggesting that we have a potential question there, which is what we see. And then, what else can we do? Okay, let's think about this one. How will we solve this one? Well, to solve the value of P, we would need the equation of EC using the gradient of the radius there. So we can find the equation of EC. In the equation of EC, we substitute -7. It gives us the corresponding P. But now, T still remains elusive. But what we can do, if we get the equation, the point C, using that as CM, we can find the equation of this line. Now the equation of this line meets the circle there. So what we can do, we solve this as a point of intersection, simultaneous equations. Then we can find the coordinates of T. And yeah, that's about it. So literally on this question, we can actually do everything, or at least every point we see, we can work out. So this is not bad. Normally in the grade 12 question, we don't get so much luxury. So now that we see that everything is within reach, we don't really need to skim and scan here and see if we can handle everything. We can just go for it. It says write down the size of CEM. So we know that CEM is 90 degrees. Okay? Question said write down, so we never need to justify. Of course, we know that the tangent is always perpendicular to radius, but at this point, for 1 mark, we don't worry about explanations. 4.2, we need to find the equation of the tangent EC in the standard linear format, which is easy. So first of all, we need to suggest the points. M is 3 and 0. Without saying this, we have not said anything, okay? Remember that we need to state, of course, by inspection from the equation. So we will say then, okay, we can say also, we know that the gradient of EC multiplied by the gradient of me, must be -1. Right, the reason is we already set the angle, so we're not gonna explain this. So this implies the gradient of the Eastern Cape into y at E, right, minus y at M, over x at E minus x at M, should give us -1. And we need to be patient with this calculation right here and not take it too lightly. It might be useful along the way, and we never need to say things more than once. If we've said it above, we just say so. Y at E is 3 minus y at M is 0 divided by x at E, this is -1, minus that one is -3. Which is equal to -1. Please be patient here. Showcase everything. As you can see, sometimes questions are scaffolded. So this is going to be -3 over 4. Okay. That bracket didn't come out nicely. So this is a positive gradient. So we know that the gradient of EC is going to be the negative reciprocal of this one. It's going to be 4 over 3. Of course, it's a fairly steep gradient, so we can accept it. So this 4 over 3 is coming up again. Okay, so what are we going to say? We will say then, we know that basically EC as some line or vector is such that y is equal to 4 over 3 x plus c. Through point E, which is -1 and 3, it will be such that 3 is 4 over 3 into -1 plus c. Therefore c, remember this is -4 over 3. When we transpose, it becomes a plus. 3 by 3, that's 9, plus 4, that's 13 over 3. Okay, so therefore y is going to be 4 over 3 x plus 13 over 3. Okay, now let's see what's 13 over 3. I'm feeling a bit dizzy now. This is 4,3. Okay, this is 3, 4, some change. Proportionately, it's not too bad. So we can accept this answer. Please, guys, interrogate the answers so that you don't miss out on easy marks over just getting outrageous answers without noticing because of perhaps a wrong input or just pure carelessness. Now, how do we score these 4 marks? We need that point. Very important. This time around, we're getting a mark for this gradient and the mark for that gradient. Okay. So here, hi. What about the C value? What about the substitution of this point? My lord, this should have been 5 marks, guys. Examiners, kodwa. No, nyasmosha, and the moderators and whoever, quality assurers. Come on, guys. In fact, cut some questions out. They are irrelevant. Let the students sweat. For example, why do you need this question? Really? Why? Why? This question is not necessary. Transfer this mark down here. Question 4.1 was truly unnecessary. For a grade 12 student, you should not be asking such questions unless you have enough marks for each. But for this one, it justifies 5 marks then, you know. In fact, even 6 marks if you think about it. But hey, asingathethi kakhulu, sizawumosha ixesha. So 4.3. 4.3, we need the length of DM. Okay, we saw this one. It's going to use our triangle. So we'll just say in triangle DEM. Damn. What are we going to say? We set up Pythagoras theorem, right? But we need to state something. That essentially EM is going to be equal to the radius of circle M. Therefore, EM is going to be the square root of 25, which is 5 units. So this time around, we're not interested in beating around the bush too much. But we get marks for stating that, right? We will definitely have a mark there. We will then say, then we understand that dm squared, which is the hypotenuse side, is equal to ed education squared plus em squared. This is from Pythagoras. Right, so this implies that dm squared is going to be ed. We are given this is 15 over 4 squared plus this one is 5 squared. So this also implies that dm is going to be the square root of 15 over 4 squared plus 5 squared. Therefore, dm is that. So what do we see here? 15 squared is 225, ne? How to see one? Yes, it's 225 over 16. This is going to be 25, right? So 16 times 25, but long multiplication, guys, it's 400, ne? 16, got to see born. So this is going to be 16 times 25, ne? So 5 by 6 is 30. 0, we carry the 3. 5 by 1, that's 5, plus 3. that's 8. Hi, ngathi seyiqale wrong. But 30 must 1. Then we carry that one. 5 times 1 is 5 times 1 is 5 plus 3, that's 8. Okay, maske siyeke kanjalo. Then we put a 0 because we're going to use the tens now. 2 by 6 is 12, so we write 2, we carry 1. Then we say 2 by 1, that's 2, plus 1, that's 3. So we add these things now. So this is 0, this is 10, that's 0, we carry the 1, 1 plus 3, that's 400. Yo, you need to be able to do this in your head, guys. This is how the so-called geniuses, sometimes you marvel at people doing a calculation and be like, it's gonna be, actually they're doing long multiplication, okay? They have a board somewhere in their brain. Okay, so this is gonna be 400 plus 225. Is what a calculator and cartel. This is 625. Right. Now 625 is what? Is 25 squared, isn't it? Yeah. Over 16. So we will have square root of 625. That's 25 over 4. Okay, let's put it on the calculator. Before I mislead people, sometimes this brain of mine is too small, guys. Do not trust it too much. It's not that big. Even my head is small. It's only getting fat now because I'm getting a bit fat. Yeah, it's 25 over 4. Remember, this is units. Don't forget. Now, folks, we said we're going to say this minus 3. It gives us the coordinates of this one, but it's going to be the negative version, minus 13 over 4. Nice and easy. So remember that. So if ever we need to do something, we know that we can do this. From that dm, we subtract 3 and multiply it by negative. And that's what we have. If we ever need it. We don't know if we need it now. So what do we do now? We get a mark for this one. Substituting into the Pythagoras theorem. And the answer, provided we say units. If we don't say units, we are essentially do what? Okay, guys, let's move quick before I waste your time. 4.3. No, that's 4.4. Okay, 4.4, we need to show that P is whatever. So 1 mark. Okay, guys, we've got the equation of EC. So this is fine. So we know that EC as a vector, where's a line, is y equals 4 over 3 x plus 13 over 3. Okay, so we're just going to put C in there, which is minus 7 is to P, such that P is equal to 4 over 3 into minus 7 plus 13 over 3. All right, so what do? We will then make a conclusion. Let's see. This is minus 28 over 3 plus 13 over 3. So 28 minus 13, that's like 15. So this is minus 15 over 3, which is going to be minus 5. Good. So it comes up nicely. So if this is right, it confirms that the equation we calculated for EC is correct. So sometimes the examiners are that friendly. They provide you a way of finding out if you are aware enough, of course. So literally here, guys, it's just the substitution that matters. The rest is not that elusive. 4.5, we need to calculate the coordinates of S. If SEMC is a parallelogram, okay, with x less than 0, not a big deal. We can see there that if x is less than 0, it's really suggesting that x at S, less than 0, suggesting that this is either a point in the third quadrant or fourth quadrant. So let's start acting accordingly. So this one, we're gonna just draw a nice line here. Okay, maybe let me choose a different color. Of course, you don't have this luxury in the exam, guys. You just do a rough sketch. For me, I can do things. So this, all right. Come on, bruh. Move when I'm on. See, this thing of doing things in front of you is bad. Because, guys, mina ngine technology, nina aninayo, so ningazami nokuyizama lento le. Engiyenza laphana, yabona sungiqhela, manga because khewu up. We don't want it as khewus. So the kewus must not exist. This was 15. Okay, we just want to re-show it. So of course, this is our palm. Now, folks, remember, how do we name a parallelogram or just a quadrilateral? Remember, S must directly link to M uninterrupted. E must directly link to S must directly link to E. E must directly link to M uninterrupted, and M must directly link to C uninterrupted. So this is why we know that point S must be here. Okay, so we see S links directly to E, E to M, M to C. See that? That's how we name it. Otherwise, we can't say E, C, M, S. You see that crisscross? No, doesn't work. Okay, so know how we name things. Okay, guys, let me not waste time. I'm gonna waste it talking. Now, how do we deal with this, guys? So we already see that there's a diagonal EM. So if we find the midpoint of EM, we will be in a good position. Okay, but how do we then ascertain where this is? So we literally are going to try and find a diagonal also from this point to there. All right, okay, all right. So what do we know about the diagonals of a parallelogram? They bisect each other. So we can just cut this one so that it doesn't hide what we have there, while it just serves the purpose of solving our issues. Okay, we said that was 0. Okay, I don't want it to hide my information. So with a pencil, you can always make sure everything is visible, because remember, you still want to present this to the markers. Remember that annotated sketch must say the things. So we can let this be point F, since we don't have any F here. So just choose a point that you don't have and name it, but you're going to state it here. Okay, great. So we want to do this so that this is the midpoint of this line. But what do we know? We know that diagonals of a parallelogram bisect each other. All right, trying to find a place. Okay, something like that, so that it's visible. We don't want any interruptions of anything. Okay, so diagonals of a parallelogram bisect each other. Since this is a parallelogram, we know this side must be parallel to this side. And not just parallel, but equal. Okay, we can use 1. This one we use 1. 1, so there was this red thing there. We can use the red thing. Okay, so we need to stay. See, the radius is equal to that. If we ever need to use some distance formula, perhaps we could. Again, we could find this and use that, and perhaps simultaneous equations to find s. We can do that, but that would be a bit tedious. At the same time, we can use the gradient of this line and this point, find the equation there, use the gradient and the gradient there, using that point, find the equation, solve simultaneously for s. So there's many ways, but others are going to be labor-intensive techniques, which we are not interested in showcasing. So let's just use, we're going to say let f be the midpoint of EC, right, such that f is going to be x at C plus x at E over 2 is to y at C plus y at E over 2. So this implies that f is going to be x at C is minus 7, and that at E is minus 1, divided by 2 is to y at C, we got minus, what? Minus 5, ne? So this is minus 5, and minus 3 all over 2. Okay, great stuff. So therefore our point F is, this is minus 8 divided by 2, it becomes minus 4 is to, this is again minus 8, minus 8 divided by 2, that's also minus 4. Okay, wow, but this one is a bit strange, isn't it? No guys, we are adding, we're not subtracting. Yo. I'm falling into the trap of subtracting. Remember, this was a plus originally, so if it is positive, it's positive. Yo, this is minus 2 divided by 2, that's minus 1. That's a bit better. Proportionally, you can see. See, sometimes when the answer doesn't make sense, guys, the sketch helps you to say, it's ridiculous. So we have point F. Now, how do we use point F? Because we're going to use it as a midpoint of SM. So we will say then S is going to be such that x at S plus x at M over 2 should be the x at F. Likewise, y at S plus y at M over 2 should give us y at F, right? Now we need to put some justification for this. We can't just say it. Why is my equation flying? Okay, how do we justify this? We can say diagonals of a palm bisect each other. Okay guys, this is to show that we understand what we are doing. We're not just going through the motions. It means S is like this. X at S plus that at M is going to be plus 3 over 2 is equal to minus 4, which I can accept. Right, is to y at S. Y at M is 0 divided by 2 should be equal to minus 1, okay? So therefore we know that S is going to be, cross multiply, minus 8 plus 3, minus 3 is minus 11. cross multiply, they'll get minus 2. Okay, well, if we got minus 1 at f, this is a point lower than that, since this is a sloping line, so it makes sense for this to be minus 2. I would accept the answer, although it may be wrong because of, you know, some technicalities, but essentially from my sketch, I am home free. So can you see, this simplifies a lot of work. Finding two equations, you know, simultaneously solving, that's a lot more work than this. But of course, when something doesn't make any sense, you just want to name something that was not there, which is a means to an end. Name it, then show it. Now what matters here, guys, is these coordinates, I suppose. How many marks are we scoring, by the way? 3, yeah. That is more important. Perhaps these two coordinates as a result, because this formula is more or less the same. I suppose that's how the marks come about. But for me, this statement is technical in nature. Without using it, we would not be making sense to anybody. So this should be, yeah. Well, we can decide depending on how the examiner feels, but I would feel this is too powerful to ignore, and maybe 1 mark for the final answer. Okay, whatever. That's just my take. Otherwise, I am not anything significant in this regard, so take my rambles with a pinch of salt. If at all you love salt. 4.6, let's move, guys. I'm losing time. If the radius of the circle centered M is increased by 7 units, determine whether S lies inside or outside the new circle. Support your answer with the necessary calculations. Easy stuff. So we know that the new circle center M is going to be such that x minus 3 all squared plus y squared is going to be 5 plus 7 all squared, which implies that we have x minus 3 all squared plus y squared is equal to 144. Okay, nice. So we can say, look, point S is minus 11 is to minus 2. It becomes minus 11 minus 3 all squared plus minus 2 all squared is equal to 144, which would imply this is minus 14, right? Minus 14 squared. Is it 1 something? 198. 14 squared. What is it, boy? 14 squared. 196. Okay, ndiphose kancane. Ndandizazi ke tani ezi square numbers ndisengumfundi, but ngoku sendiyabheda. So this is 196 plus 4, that's 200. And 200 is certainly not equal to 144. First and foremost. So if this is the case, what does it mean? It means this point doesn't lie on this circle. Now the question is whether it's inside or outside. Then we look at this value. 200 is greater than 144, so this means this is outside. We can say since 200 is greater than 144, this implies that S, or maybe let's write it, point S, my S now looks like a 5. Point S lies outside the new circle M. Okay, very important, guys, to answer in full and understand how to do things. First of all, this calculation is key, and to substitute a point is key, and to make a conclusion that it lies outside, provided we have some reason for it. That's the third mark. Nice and easy. So we've got full marks there. All right, so 4.7. Yeban, anidini wanayantu ukubuza nina. Hayi alikhathali man, kadze lisibuta laka, sikhathele goje. Hayi, siliseni, sikhathalele thina. Asisafuni kusebenta goje, sikhathele. Ha, konini lisibuta? Alitzinwa kansi lijane lona. Niyasazi isiphuthi. If it is drawn, ndingasemount Fletcher ke bafethu. Khuleni thithi isiphuthi, isuthu nesixhosa. Yayiva yongulento injalo. So sinabephuthi ba. Not abephuthi, baphuthi. Sinabaphuthi. Ibhake abakhuluma sports batothi sinane baphuthi. Yayiva yoko kuletho. Kekjeti. If you didn't understand that, I just told you that I grew up in Mount Fletcher, Ezingonyameni, in the location, if you wanted to know, in the subsection called Edutwa, Kasemfuleni Machibini, Eva Yongulento, eduze nesikolo iJongisizwe Junior Secondary School, and there's by Bezanton, mhlambe seyachange. Danifunda pha. I spoke Xhosa and I was trying to speak in English. Hey. I was studying there in my village school. Now, in that village, we have a tribe of people called Baphuti. This is more of a mixture of Swati, Zulu, Hlubi, and Sotho, because it just tells you exactly where they come from. They come from all those tribes when they came together, sort of. Of course, this is me just trying to be logical about it. I don't know how they came about. Sadly. But the language, listening to it, it's more Swati, Sotho, Zulu, Xhosa, Ndebele, zonke bonke sifakwe pha. Yes, and yes. Now we are told a new story that it is drawn. Let's choose another color that we can see. Nice blue there. So this ET is drawn. We knew that we're going to have to deal with T at some point. My Lord. Now, this ET is drawn. We need to calculate the size of ETM. Holy. So we need this angle. All right. So, well, seeing that this triangle ETM is an isosceles triangle, we also know that that angle right there should be equal to ETM, since this is isosceles. Okay, we can see that. So, you guys, usually this is one of those questions you would want to not do. Okay? Because they will take your time and you'll probably get it wrong. Now, how do we deal with this one? Okay, all right, okay. We will see that, well, what becomes an issue here is this center angle. So this center angle is split into two angles. One from the x-axis like this. Let's put an arrow there. We got that component, and this component is alternate to this component. Okay, so it alternates with that one. Maybe let's show it a bit better. There's a lot of notations here that are gonna come into play. So like this. It's too small to see. Lord. Okay. If you don't see it, you don't see it. It's not my problem. So we can see that since this is a parallelogram, So those two are alternate, with the transversal being the x-axis. And on top of that, we've got the other component. Let's make it 2 red for danger. We've got that component. Okay, so that component is basically made by the gradient of the line EM, which we did use above. So can you see, solving issues here makes life a lot easy. So EM, did we use EM, the gradient of EM at any point? Yes, we called it me or ME. So can you see that gradient is going to give us that little angle? So we'll literally have the center angle. Since these two are equal, we can use that fact to our advantage. Okay, so sometimes you just map out the best approach, not necessarily the only approach, because if you think about it, we can actually work out the coordinates of t, but it's going to be a bit tedious. How? We've got CM, we've got 2 points, we can work out the equation of this line. Then we've been given the equation of the circle, so they are intersecting here. So they will solve simultaneously, we get the coordinates of t. From there we calculate ET, the length of ET. That's good. From then on, we know this is 5, this is 5, so we can use the cosine rule on this triangle. Okay, that's gonna be a lot of work, but hey, it works, guys. So if it works and you saw it that way, deal with it that way. Don't shy away just because there's a shorter way or even a better way. Okay, let's get to this business, guys, before we lose a lot of time. So what we're going to say, I'm going to say this and say it once and for all. So I will say, well, I want to first describe this angle, but since I don't know this one, I will call it beta, right? Because I don't know this point and I don't want to know. And is that all I need? Yeah, that's about it. That's about it, because this one I can name it using the stuff that's there. So we're going to say let beta be the angle of inclination of SE or ES. All right, so this is good because we are not going to talk about beta that nobody knows. But of course, annotating it, it's nicer, but we need to also direct the marker into that. What are we going to say, guys? We're going to say, well, we know that basically DME, DMT, this little black angle is equal to alpha, or sorry, beta. How do we know this? These are alternate angles with SE parallel to CM. In parallelogram, SEMC. Okay, we're just trying to be very clear that, yes, we understand things. But even if you didn't think of this as a parallelogram, if you take this line and produce it perhaps a bit more, in case you are wondering, why am I doing what I'm doing? If we produce this line, do you understand that it will form its angle of inclination there? But this angle is vertically opposite that. Since this is the same gradient as that, we are literally doing the same thing. So if you're more convinced with this, it's okay. Just say CM produced. The angle of inclination is going to be, maybe you call it alpha, if you will. So alpha and beta are going to be equal because these are corresponding angles. Or we can look at it in terms of this gradient and work it out. Okay, I'm losing time again saying unnecessary things. So this implies that DMT is going to be arc10, right, arc10 the gradient of SE. Unfortunately, we don't have it anyway. So we're going to have to deal with this systematically. DMT is going to be arc10, of y at E minus y at M over x at E minus x at M. Of course, some questions, guys, are annoyingly tedious, a process to follow, but hey, that's what makes you better than others. You can deal with tedious things while maintaining composure. Y at E is 3 minus that at M is 0 divided by x at E is minus 1 minus that at M is like this. Yeah, man, didn't we talk about this? Oh no, that was the equation of the tangent. Yikes, that sucks. Alright, so it's not a big deal. We never talked about SE. Now at this stage, since this is the last question, we probably are not going to need this, so I can just go straight into the answer. But if there was a question after this, we would need to uncover that gradient. But this gradient is nothing but minus 3 over 4. So, something is fishy here. Minus 1. Wait a minute, what am I doing here, guys? Oh, this is wrong. Y at E. I said gradient of SE, not M. Here when. Okay, I'm losing focus now. This is wrong. At E, Y is 3 minus that at S. I don't know where M came about. M was the big deal. Okay, so big mistake there. So this is 3 minus 2 is going to be plus 2 over. So what did we say that was? Yeah, minus 2. So it's going to be 3 minus 2 is going to be plus 2. And then here x at E is minus 1. Minus 11 is going to be plus 11. Yeah? Yeah. So this becomes 5 over 10, which is a half. So we're going to say shift 10 of 0,5, literally. It gives us 26,565. Since this is an intermediate answer, we just want to increase the decimals here. Okay, all right, okay, so that's number 1. So we got the small component done. Now we need that red one. We can say also, we can say even likewise because it's a similar thing. But the first one was a bit lengthy. So also we understand that EMD, right, that one is equal to the absolute value of arc 10 of the gradient of EM or ME. Let's just say it me since we said me above. Right. Now absolute value, because I know it's a negative gradient, so, and I'm looking for that negative component, so it's going to come out from here. So if we take the absolute value, of course you guys don't know what this is, but hey, I'm teaching you now. You've got to know mathematical terminology and notations. So this is going to be arc 10 of, we said the gradient of me above was what? Minus 4 over 3. Sorry, minus 3 over 4. Can you see doing it was good enough? So minus 3 over 4. So therefore, EMD is, so of course we're going to say shift 10 of minus 3 over 4. It gives us, remember absolute value says this thing, even if it comes out negative inside, we take the positive answer. That was the purpose. Now this one is 8,870. It forces me that path straight up. All right, so this is qual. Now I've got that component. Now this is an isosceles triangle. We can say then, what are we going to say? We can say in triangle EMT. Okay, issues here are such that we know that this angle we're looking for, ETM plus EMT, right? Plus, what is the other one? TEM. Must give us 180 degrees. This is the sum of angles, not just angles, sum of 3 angles of a triangle. Okay, basic rule right there. This implies that 2 times ETM plus this EMT is made up of these 2 angles that we got. So this is going to be 26,565 degrees plus 36,870 degrees equals 180 degrees. Again, why? We know that ETM is equal to TEM. This is because of angles opposite equal sides. Now the sides here are the radii MT or TM and EM or me. Okay, of course I'm just trying to say a lot so that I am clear to you, the one who's looking, even the one who's marking. Try to think for them so that you don't lose marks. Now we understand that basically this implies that ETM is going to be 180 degrees minus the sum all right, all of this is divided by 2. Therefore, ETM is going to be the answer. So we've got 180 minus the sum of 26,565 plus 36,870, all of that divided by 2. What is the answer there? I'm getting 58,28 degrees to 2 decimal places. Okay, if we look at our diagram, it looks almost like an equilateral triangle. Equilateral triangle has 60 degrees. So we can see that this is almost 60. I mean, 58 is close. Of course, this is not to scale, but I mean, look at the proportions. This one, of course, looks a bit slightly big. I mean, those two added together, they would be around about more than 60%. Yeah, maybe 62, some change. It's not far from 60 otherwise. So, yeah, we can accept this answer, although it looks strange. Of course, this is the essay type question, guys. I don't know if there's a quicker and straightforward way, but sometimes don't be obsessed over those. How you see it, you solve it. So now, folks, what is important here is this angle and this angle. And of course, this portion here, when we justify that these two are equal, the sum of angles is not a big deal. And the answer here, so we've got 1, 2, 3, 4. Okay, where's the 5th mark? Well, the fifth mark is calculating this gradient. So you can think of it as substitutions versus calculating the gradient. But since it wasn't given, we must get it right. Or one can think of this one right here. Either way, it will depend on the examiner. Of course, these are the questions that are annoyingly long, but with not so many marks in them. So sometimes if you don't see it, run away, because it's a waste of your time on better things, and yet you may just fail it even after trying it out. Okay, guys, that was the mark of a beast. The mark of a beast. So yeah, there's 20 marks. There was some easy questions and some tough questions, which is typical of the grade 12 question. So I hope we understand each other and we have been moving along nicely together. If not, well, too bad. I tried though to write this as clear as possible, and I hope it's easy to follow. Okay, let's get to the trig. So, question 5. So question 5.1, very easy stuff. Cos theta is equal to minus 5 over 13. So we know that we need the Cartesian plane there. Alright, so if we look at this, cos is negative in the second and third quadrants, but less than 360 more than 180 makes it the third quadrant. So it means we are working on the third quadrant here. Origin. So it means our terminal arm is here. Alright, so it's not always nice to do this. Bona izongihlanyisa guys. And ke ngoku andifuna ukuhlanya mina. Andizimiselanga nje ukuhlanya. Okay, akho kanti ndizayisula. Eish guys, yabona ngoku ndiyaphambana ngoku. Ndiyaphambana ngoku. So since this was a construction, we might want to do it. So we know that this is our theta. It's a reflex angle. So show everything. And here we can see that we can easily work out cos is minus 5 over hypotenuse. So that should be 13. So x squared plus y squared should give us r squared. We know this from Pythagoras. So this means x is minus 5 squared plus y squared is equal to 13 squared. Therefore y here will take the square root. This is 169 minus 25. It gives us 144. Square root of 144 is 12. So this should be minus 12, right? Have to see check. 13 squared minus 5 squared. It's 144, yes. Taking the square root of the answer is 12. Remember, this would have been plus or minus 12. But we're choosing the negative because this is the negative y-axis. So this is 12 over there. Minus 12, sorry. Nice and easy. So let's start answering 5.1.1. We need to deal with sine squared theta. So this is going to be basically sine of theta all squared, which is going to be equal to sine of theta is minus 12 over 13. Then we square it. Then we get our answer. 12 squared is 144 divided by 13 is 169. It's an even number divided by an odd number, so we shouldn't have a factor there. So we leave it like this. We can simplify further. and we don't want decimals. So good. First and foremost, we get a mark for that calculation, defining sign, and the final answer. So 3 marks, nice and easy. 5.1.2, we need to deal with 10 of 360 minus theta. Okay, so when we reduce this, it becomes minus 10 of theta. 10 theta would have been positive because this is in the third quadrant, but now we are dragging a negative, so this is minus into minus 12, opposite over adjacent, which is minus 5. So a negative divided by negative, maybe let's just try to make this division line a bit more accommodating. Minus 12 over minus 5. So this is nothing but minus 12 over 5. So it becomes negative because of dragging that negative. So we pushed it around, so basically doing the reduction is key. And essentially the final answer, it seems. Okay, good. 2 marks in the bag. Now we've got more work on ourselves. So can I squeeze in this one? Let's try 5.1.3. What do we have here? Cos of theta minus 135. Okay, now this one is an angle in the third quadrant. Minus 135 is an angle in the third quadrant. It's an equivalent of 225 degrees, right? But if you say this plus 360, we get 225 to get a positive angle. So yikes, it doesn't help us, so we need to use the identities here. Cos of the first angle, cos of the second angle, the sign changes, sine of the first angle, sine of the second angle. Okay, so nicely done here. Cos was given as minus 5 over 13. Now cos of 135, remember this is a special angle. It's technically 180 minus 45. Cos is going to be negative. Yeah, it's going to be negative cos of 45, which is 1 over root 2. Okay, good. We've got sine theta here. Came out as minus 12 over 13 into sine of 135 is as good as sine of 45, which is 1 over root 2, which is positive. So we go on. So what we have here is basically 5 divided by 13 root 2 minus 12 divided by 13 root 2. Okay, I'm gonna kind of write it there. I hate to write like that, but because of space, I would rather my answer is here. So common denominator is 13 root 2. So 5 minus 12 is minus 7 over 13 root 2. Nobody said we need to rationalize here. So we can stop it right there. So first of all, identities, special angles, final answer. How many marks? 4. Then we can say the general substitutions. Who knows? Whatever. Okay, all right, okay. One may want to entertain the sine 135 and the cos 135, giving marks for that rather than substitutions in general. It's not a big deal. 4 marks should be enough. Key is that our job is done. Okay, all right, okay. So is over, is done. Okay, let's do 5.2. Oops. 5.2, we need to simplify into a single trigonometric term. Okay, not a problem. 2 cos of 180 degrees minus x times sine of minus x divided by 1 minus 2 cos squared of 90 degrees minus x. Okay, three-step approach. It's already in my head, so I've got 2 into, we reduce this. 180 minus 4 cos is going to be minus cos x. Okay, into this sine of a negative angle is going to be minus sine x, all divided by 1 minus 2 into, now when we reduce this, perhaps you may want to do this and say big bracket just to be consistent. This is cos of 90 degrees minus x all squared. Okay, you need to know how to simplify this properly so that you don't make mistakes. So negative times negative is positive, so we end up with 2 sine x cos x. Just so that we can set up our identity nicely. Now we come to the bottom. It's 1 minus 2 into, now this is going to be cos of 90 minus x. Now this is positive sine x using co-ratios, so this should be squared. Alright, so this is basically, we simplify this one. Maybe it's too soon. Let's say 2 sine x cos x over, this is 1 minus 2 sine squared x. Okay, good. Now using identities, this is the same as sine 2x over, this is as good as cos 2x using our identities. So sine of the same angle divided by cos of the same angle is just tan of that same angle. Nice. Oh, sure, my student, I'm going to get to them a bit later. Not a problem. Good. So, how do you test this? Just say x is some 2 degrees, any angle. And then you substitute this here, and then you substitute it here, and see what you get. Okay, so easier is tan of 4 degrees basically. It becomes some 0,0699. Okay, we can stop there. Then we come back to that one. So we need to be able to use brackets there. 2 into cos of 180 degrees minus 2. Okay. Into sine of minus 2. Okay. Brackets, guys, must be on point here. 1 minus 2 into cos of 90 degrees minus 2. That must be squared. Okay, just make sure your brackets are, or math error. Okay, minus 2 into cos. What did I do wrong? Oh yeah, I left out that bracket. So brackets are key here. So I'm getting the same answer. So what does this mean? It means our reduction is perfect, okay? So that's very important because you may have made a mistake here. So what is important is these reductions first and foremost. Those reductions are key. Ne? Nice and easy. So when we use identities for the numerator there and identities for the denominator, so 1, 2, 3, 4, 5, and the final answer 6, still using identities. And that's the 6 marks. Nice and easy. So we've got 5.3. It says calculate the value of the following expression without using a calculator. Okay, 1092, 1094, 1096. Oh, hey, 92, 94. Hey, ngathi sentweni nje apha, 96. Okay, so what we can see there's 176 and 178. How do these angles relate, guys? Now we can see basically this pattern. You see this dot part here? It simply says this pattern continues like that until it ends. So what it means is that each angle increases by 2 up until we got there. All right, okay, all right, we can see that. So we're going to copy this expression first. So this is 10 of 92 degrees. Do I really need to put it in brackets? 10 92 degrees. Okay, let's write it as it is written, into 10 94 degrees into 10 96 degrees, dot. So if I've got my first 3 terms here, if this continues, I just need my last 3 terms. So this is going to be 10 of, so of course if this is 76, 78, that should be 74. So this is 10 of 74 degrees into 10 76 degrees into 10 of, don't go. Don't isn't this balap. So I see that I'm gonna need space, so masibeka up his hands. So this is gonna be 10 of 174 degrees, right? Because these are increasing by 2 times 10 of 176 degrees into 10 of 178 degrees. Okay. So we have a situation now that, okay, we've added, sometimes when there's a pattern like this, always try to add some terms in there so that you can fully see what happens. Because if you don't, you may not see what's cooking. Now, guys, we don't see any, these are not special angles at all. Okay, we have a problem, but we can create some special angles if we will. This is hard, but 10, we don't normally work with 10. So can we change this to cos, maybe? Sine over cos. Okay, let's see. First of all, okay, let's say this is equal to, basically this is 10. Well, this is sine, but what I want is to use cofunctions. So 92, oh guys, I'm so lazy to write. This is 10 of 92. Okay. Let's first convert this to sine and cos. So this is sine of 92 degrees over cos 92 degrees, okay? Times, this is going to be sine 94 degrees divided by cos of 94 degrees times sine of 96 degrees over cos of 96 degrees, dot. This becomes sine of 174 degrees over cos 174 degrees times sine of 176 degrees over cos of 176 degrees times sine of 178 degrees over cos of 178 degrees. Okay, this is what we have. Of course, with something like this is more like a higher grade question. Again, those algebra questions, 1.3 kind of questions, this is typical. So we need to work systematically up, huh? So what can we do, guys? Equal to. So now we can try to reduce this. Remember, anything more than 90, we reduce it to some acute angle component or equivalent. So 92 is as good as sine of 90 degrees plus 2, right? So now I'm gonna be quick because I'm only getting 4 marks. So this is as good as sine of 90 plus 2 changes to cos of 2 degrees divided by, now cos of 90 plus 2 degrees, this is going to be minus sine of 2 degrees. Okay, times sine of 94, same thing, is going to be cos of 4 degrees divided by minus sine of 4 degrees, isn't it? Following the same pattern. Times 96 is going to be cos of 6 degrees divided by minus sine of 6 degrees. Come here. Now these are big ones. So big ones, it's 180 minus. Ne? So let's see. 174. It's going to be 180 minus 174. That's 6 degrees. So this is going to be, again, same function this time. So sine in the second quadrant is going to be sine of 6 degrees, sorry, using reduction formulae. So guys, I don't have space to write it nicely extended like that so that we can reduce. So I hope you follow. Now again, cos, same function, but this time it becomes minus cos of 6 degrees. Remember, bigger ones like this, we're not going to use cofunctions. Times sine of 176, this is the same as sine of 4 degrees divided by minus cos of 4 degrees, isn't it? The same pattern follows. And then times, this one is going to be sine of 2 degrees, right? 180 minus 2 gives us 178. This one is going to be minus cos of 2 degrees because this is in the, in the second quadrant. So we're doing reduction formulae. 3-step approach, folks. 3-step approach. Identities, cofunctions, and, reductions. Anyway, so what can we do? Now remember, this is a product. Everything is multiplied. So what we multiply together is of our choosing, right? So can you see though that cos 2 degrees takes care of cos 2 degrees? Nice and easy. And since this is a product, this will sort of like divide. Sine 2 degrees takes care of sine 2 degrees. Nice. That goes away. And then cos 4 here will be taken care of cos 4, because whatever we multiply, this is what happens. They will divide nicely. And then sine 4 as well nicely goes. Guess what? That and that goes. And that and this goes. So if everything disappears like this, it means everything in between will disappear the same way. But now we need to be smart about our business, because now we need to know how many are these terms first and foremost? Should we regard them as terms? This is one single term, but in terms of brackets, how many are these? So that we can think about these negatives, because now there's negatives on the denominator. If we look at them for now, this multiplies, let's just say this negative, because this one started going, this goes with that, so it becomes positive. This goes with that, it becomes positive. This goes with that, it becomes positive. So if everything disappears, then we should be good, because it means everything goes. So let's say from 92 to 178, how many do we have there? How many terms do we have? Remember, if we look at these angles, now we need to be smart here. 92 plus 94 plus 96 plus dash 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 plus 178. We know that this is an arithmetic series, right, with a difference of 2. So we can say, well, Tn is equal to 178. And what do we know? Tn is A, which is going to be 92 plus n minus 1 times t, which is 2, is equal to 178. So we know that n minus 1 is going to be equal to, now let's see, this is 178 minus 92, which becomes 86 divided by 2, it's 43. And we add 1, so n, this is 44, so these guys are 44. It's an even number. Now remember, this is too big. Now let's just cut this into any even number. Let's say there were 4 items, right? So we've got 1, 2, 3, 4. Do you see this one took that and this one took that? So if this is negative, this is negative, this is negative, this is negative. So guess what? Everything is going to disappear. There's no remaining that doesn't have a match with an even number. So guys, you just work it out nicely on your rough work and work out things. So you will see that everything disappears. Even these negatives, they are taken each time. So when we multiply those negatives, what happens? Because this times that is positive, this times that is positive, this times that is positive. So everything is positive. So this simply says everything will disappear. And we only have positive ones on the numerator. We've got negative ones on the denominator, but such that it's an even number, so these negatives disappear. So all we end up with is 1. Okay? Because 1 times 1 times 1 times all these other ones times 1 times 1 times 1 is just going to be 1. Minus 1 times minus 1 times minus 1 times minus 1 times, that's going to be just positive 1. So 1 divided by 1 is 1. Wow, that was an interesting question. Yeah, certainly a higher grade question. So if you don't think at that level, these are the questions you just want to abandon. So what do we do, guys? First of all, changing everything to sine and cos, I suppose, is a mark. Great. Secondly, the mark here is for the reductions. First and foremost, on this left hand side we used cofunctions, maybe we can say 1 mark. And then on the right hand side we used same functions, maybe 1 mark, I guess. It's quite complex, right? But since we kind of looked at it in 2 aspects, I would appreciate this. And then the final answer. So we've got 1, 2, 3, 4. I think that's how we get the 4 marks. Of course, we will see with the formal marking guidelines as to what to do here and how much is on offer. So of course, we finished this question, which was a bit silly at the end. Otherwise, the rest was the standard stuff that we do. All right, let's do question 6. Question 6 says, prove that 2 cos squared whatever is equal to this one. So obviously, folks, anything with brackets and squares is more complicated than that. So let's see, can we do it? 6.1, we've got 2 cos squared 45 degrees plus x equals 1 minus sine 2x. But if we look at this, it's also a double angle. So there's a very good chance we might need to sort this out. But let's see if we cannot convert the left-hand side into the right-hand side. So let's choose the left-hand side. Whenever we prove something, we need to choose a side. 2 cos squared 45 degrees plus x. Okay? So this is equal to 2 into, oops, why tablet are you moving now? 2 into cos of 45 degrees plus x all squared. This is what this means. This is 2 into, we expand this. Now when we expand it, we drop the square bracket. This is going to be cos of the first angle times cos of the second angle. The sign changes. Sine of the first angle, sine of the second angle. Then we square it. Alright, so 3-step approach, folks. This is BODMAS. But first we've got reduction formulae here. This is 1 over square root 2 times cos x minus, this is 1 over root 2 times sine x. Okay, all right, okay. So now, what are we going to do? Remember, this is squared. So, when this is squared, this is 2 into. Now, this one squared, it's going to be 1 squared, which is 1 times cos squared. Times cos squared is going to be cos squared x over 2. Remember, root 2 squared is just 2. Nice and easy. So minus. Now this time we're going to have this times that. So basically we end up with minus sine x cos x over 2, because this times that is 2. So now when there's 2 of these, it's going to be what? Just one of them, right? Right, so we're going to have here, basically it's going to be just minus sine x cos x, right? Plus, this is going to be sine squared x over 2. Great. So, are we clear? Let me just show you what happened in the middle there. So this is going to be 1 over root 2 cos x times minus 1 over root 2 sine x. Right, so let's see what happens here. So the numerators multiply, so this is minus sine x cos x, right? These denominators multiply, so we end up with a 2. Okay, great. Now the same thing will repeat. This times that is going to still be the same, so we're saying minus sine x cos x over 2 again. There's 2 of these, so can you see half of this plus another half of this is going to be 1 of those. Right, so we end up with just minus 1. Or if you will, we can just simply say the common denominator is 2, so we just have minus 2, because it's going to be minus 1 of this, minus 1 of that. It's minus 2 sine x cos x, right? Since this is a product, this goes, so we end up with that, okay? Just in case you didn't understand the algebra in there, so please, man, Trigonometry is just algebra 1. Is it 2.0? Yeah, whatever. I don't even understand what that 2.0, 1.0 means. I just say it because I hear people say it. Now we distribute the 2, it kills. Get cos squared x minus 2 sine x cos x. Then it kills that one. The denominator is going to be just sine squared x. Now remember, these are like terms. So square identity will tell us that those two will combine to 1 minus. Now 2 sine x cos x is as good as sine 2x. Isn't it what we are looking for? Definitely, definitely, definitely. This is an identity. So 3-step approach, folks, which is equal to the right-hand side. So we don't need to change the right-hand side anymore. All right, 4 marks, not a big deal. How do we score them? Number 1, this expansion using identities. Then here using special angles. Right, and then here coming out using identities. This one and that one. So that's how we score the 4 marks. The rest is your problem. Go cry in a corner somewhere and come back. Let's do maths. So 6.2, what is it? Whew. Consider the expression. So, okay. That's crazy. Now we need to prove that this thing is equal to this thing. Wow. Okay. Yeah, doch, this is crazy, is it not? It's very crazy, this one. Okay, so not a big deal, guys. We're going to use identities here. We don't have a choice. I don't even know why we need to consider this, because we should just be asked this thing. Guava. So 6.2.1. We have sine A minus B minus sine A plus B. Okay, is equal to minus 2 cos A sine B. Oops, not sim. Alright, again, this is more like identities. Left-hand side looks a bit more complex. We have sine A minus B minus sine of A plus B. We expand, this is sine of the first angle, cos of the second angle. Sine remains, it's going to be cos of the first angle, sine of the second angle. So this is minus, put a bracket here, we deal with this expansion. It's going to be sine A, cos B, the sine remains, so it's going to be cos A sine B. Okay, so this is easy. We just distribute. So this is sine A cos B minus cos A sine B. This one becomes minus sine A cos B minus cos A sine B. Now these are like terms, they take care of each other. In fact, they cancel out. So these two are the same, but same sign, so they add up to minus 2 cos A sine B, which is equal to the right hand side. Okay, that one was an easy one. I don't know why it was asked. A waste of time, honestly. Okay, good, because you needed to know what to do. So where do we get the marks, folks? Technically, the expansions. That's all. The rest solves the problem. back into what we knew. Okay, I suppose so. So now for another 2 marks, simplify the following expression into a single term. Okay, wow. So 6.2 0.2. So we've got sine 4x minus sine 10x. Oh, interesting, if not interesting. So remember, it means we must say this is something like that or something like this. We need to get it to those two. So we need to say this is equal to sine. Now 4x is the same as, wait a minute. Okay, now like 4x, oops. So now means fine no 0, but now we need something that looks like that, a and b. But a and b must look like it. Yo, I can go 10 ngathi siyaqhelwa ke ngo. U4 kodwa is 2 plus 2 ne? Or 3 plus 2. But we don't want 3. We need a double angle. So this is just 2 marks, man. Why? Okay, let's just say this is 2x. Okay. I'm trying to think. But the thinking is not thinking. The thinking is not thinking. Because I want A and B, man. Okay, must see go 2 plus. But if it is going to be 2 plus 2, it's not going to be good. Sine 10x is going to be... Damn, this question. Man. I want A and B. Kanjani, some creator kanjani, guys. Damn it, man. Damn it, man. I'm not exactly pleased here because for 2 marks, guys, this is not right. This is not right, man. It's not right because I'm not going to be able to get 2 angles that look the same. 10 is 8 plus 2, 8 minus 4. So 2 and 4 are not the same. I need the same angle A, like that. Damn it, man. This is a higher grade question, although it looks crazy. Another stumbling block, and now that means our time gets chowed. Thinking. Yes. So we need an angle that can fit into 4 and 10. In a way, but is there no error then? Because it can't be 10. 10 is 8 plus 2. 4 is 6 minus 2. But 6 and 8 is not the same thing. 4 can be 10 minus 6 and 6 plus 4. But my problem is that 10 minus 6 makes up 4. But now what would be 10? In terms of 6 and 10. You see, that's where the problem is. Okay, guys, let's think about it a moment. So, but I think what we need, technically, guys, this question, but I think we need two numbers that when we subtract in the first instance we get 4, but when we add in the second instance we get 10. What is that? 7 and 3, right? Is 10, and then 7 minus 3 is 4. So yeah, let's try that. Let's see. Sometimes we obsess over double angles, but sometimes it may not serve the purpose. So this is 7x minus 3x. This is 7x plus 3x. So what we're trying to do is to create this. Of course, guys, these are the kinds of questions that it's not so much marks, okay? If you don't see it early, don't waste time trying to figure it out. It can hurt, and unnecessarily so, for just 2 marks. But don't take lightly those marks. If you can handle it at any stage, please try to do it as best as you can. So we can see, guys, that this thing is going to reduce to just 2 times cos of this angle, sine of that angle, isn't it? Yeah, so this is going to be equal to minus 2 cos of the first angle, which was 7x, times sine of the second angle, 3x. Great. So what is this? Simplify the following expression to a single term. Now this is a single term, right? Cos times is a single term, so there's no signs. So this is it. Wow, this question, guys, of course, remember there's 2 terms now here because of that, but now once there's nothing else, a multiplication is basically 1 term. That's gross. That's gross, okay? Anyway, 6.2.3. We are now to find what determine the solution, and we're given this. So this is now solving the equation. Okay, this is going to hurt a little. It's going to hurt a little. So in any case, we know that we are given something else now. This is telling us that sine 4x minus sine 10x is equal to sine 3x. Okay, so can you see there is the clue? Goodness, how did I not see it? There is the clue for this question above. Sometimes the examiners are naughty. As I often say though, if you get stuck in a question, usually something before or something after is the solution, or at least the idea. So look around, don't be stuck on your own. So this implies that we've got minus 2 sine 7x times, not sine but cos. We've got 2 cos 7x, right, times sine 3x is equal to sine 3x. Okay, so now the one thing we don't want to do here is to find ourselves dividing by sine, because we end up in trouble. But actually we don't. It works. We can do it whether we factorize, whether we, I don't know, will we lose a mark here? I don't think so, because I'm thinking of transposing this and then factorizing and then solving. So this in any case is going to give me sine 3x is 0. So 0 is 0, sine of 0 is 0, so nothing changes. Even if we divide by that 3, it still becomes 0. So I don't know if it is necessary. So what I'm going to do, I'm just going to divide throughout by sine 3x, such that I have here 2 cos 7x is equal to, so minus 2 is equal to 1. So what else is this? So this implies that cos 7x is going to be minus a half. Okay. Yeah, that's it. Now, what do? We know that this implies that x is going to be equal to plus or minus the arc cos of minus a half. In fact, to avoid the fraction here, say minus 0,5 plus k times 360 degrees, where k is an element of integers. Nice. This implies that x is going to be equal to arc cos of this negative business here is going to be negative, right? Arc cos of minus 0,5 gives us 1.8 helix. So this is plus or minus 120 degrees plus k times 360 degrees, where k is, k is an element of integers. Now we split these solutions, so therefore, this implies that x is equal to 120 degrees plus k. This is 7x. Hey. You see now. I'm too excited, I guess. So this implies that x is going to be equal to 120 divided by 7. Okay, this is going to be 17,14 to 2 decimal places plus k times, now we're going to say 360 divided by 7. This one is going to be 51,43 degrees, or x is equal to, now we're going to take the negative version of it. So minus 120 divided by 7, still going to be the same value actually. So I don't know why I had to waste time. I could easily just say plus or minus, but anyway, let's just sort it out. So this is minus 17,14 degrees plus k times 51,43 degrees. Let's shift everything a bit. So that we can have k as an element of integers. Nice and easy. Okay, now we can say therefore x is a set of these values which need to be in that category. Of course, minus 17 is basically greater than less than minus 30. Okay, only positive 0 to 30, so the negative ones are not that big of a deal, but let's think before we say it. First, when k is 0, we get 17,14 degrees here. When k is 0 here, we get minus 17. So minus 17 is outside, so out. 2, we say k is 1. This one becomes more than what we need is out. When k is 1 here, we get 51,43 minus 17,14. So this is basically 34. So we know that 34,29 degrees is there. So of course, once we start multiplying k by any value greater than 1 and minus 1, we'll get solutions that are way out of where we need this to be. For example, this is going to be almost 100 some change. If this is 2, then minus 17, it's not going to work. So I think it's just these two solutions. So we need to list them in ascending order. So this is 17,14 degrees and 34,29 degrees. That's all we have here. That is, wait a minute, 34 is big, guys. Hey, this guy. 34 is already big, because this should be 30 or less. So there's only one solution. Okay, guys. Therefore, x must be 17,14 degrees. Done. Okay, this question is a naughty question. If you don't take it seriously, it will take you down. As you can see, I'm going to town here, but I'm not really winning, hey? Yeah, because even if k is negative, it's not going to work. Negative is already too far, so not good. So I suppose this is all we have, guys. So basically the substitution of the left hand side, 1 mark. Solving up to here, 1 mark. Solving that, 1 mark. This is 1 mark. And then maybe there's 2 general solutions, whether up there or there, but I think these ones are good enough. Plus or minus, good enough there. So yeah, not quite a very clear one, but it is what it is. Okay, guys, you would be told time up. As you can see, this thing, no matter how fast you try, some questions, if I was to write this exam, I'll probably fail too, right? Because I'm too congested with knowledge. I would definitely not fail, guys. I'm serious about it. I would score full marks, if not be very, very, very close. If I could be very close before I was that experienced. Now I'm too experienced with this, so there's no way. I would not suffocate that exam. Of course, there's mistakes. There is sometimes overthinking things, which is time wasting. Not giving up when needing to. But of course, one thing for sure, you want to secure a distinction. So you answer as many of the questions as you can. You start with the higher order ones, or the sections that often contain higher order questions, so that after being percussed, they may be skipping some questions. Please don't be too overzealous. When a question is too technical, just skip it. Give it time. Go diffuse your frustrations and some easier questions as well. Collect all the marks while being careful. Then come back to those. You will see they will come back. That's how I did my exams, guys. I didn't have it all figured out the first time around. Sometimes I would skip, continue with others to save time. Then I would have enough time, usually, because some questions are just easy. You just go through them nicely. And then you come back to this one. And guess what? By the time you come back, you are not scared anymore, because you can see that you've done well in the rest of the paper. Then you come here with enthusiasm and the ability to think without panicking. And guess what? You solve it. Like this one. It could be a nightmare, but once you think of this, eventually, of course, because at first you would be forcing double angles because you're thinking, I have identities as I was that are double angles. But this time, they knew that the question is going to make up for those angles that are crazy. Right, all right, okay. Anyway, guys, that was easy. Okay, not easy. Perhaps not difficult, but technical, I guess. That would be the word. Okay, let's get to this one here, guys. So much time has been lost. I'm not happy. So question 7. I don't like to take too long doing these papers, but I cannot lie to you guys and pretend that me doing this was like, what, an hour and a half? No, it doesn't work that way. If you are teaching, for sure you're not. But you can see those who really don't intend to teach, but they intend to showcase their skills, which is okay. There's nothing wrong with that. But you wouldn't learn anything from that kind of analysis, honestly speaking. Because as someone speaks, if they're moving too fast, even if you were to follow this at a later stage, but you would struggle to keep up because, you know, their thinking is not your thinking. So if they don't put you into that picture first, then you're not going to follow. So my purpose here is to showcase my thinking, because it could be your thinking. If not, I'm trying to influence you to think the way I do. Because if you can follow on like that, you stand a chance of expanding your thinking ability. And that makes you even better a person than I could be. Because what you're going to come up with at the end is you and me put together. That's like a bomb. Than me alone, which is more like, you know, a cricket. It goes, but a bomb is going to be like, boom. You get it? You get it. Anyway, guys, whatever. Time is not an issue when we are doing a review, so that you can understand the construct of the paper, as well as the answers necessary to really answer it fully. Of course, there will be mistakes. If you see one and you spot it, let me know, so that others can also see it if they did not. Because some people will believe me even when I'm wrong. So you need to showcase this. It's not any difficulty for me to accept being wrong. I'm not like other people who pretend they have it all figured out. Even when they are wrong, they will just not accept being wrong. But at the same time, there's nothing wrong with that, because as a person, you should not be easily influenced. Can you see, guys? Everything we can say wrong, but it's actually not wrong. It just depends on the context or the situation, circumstance. Because at times you don't want to be too easily influenced by outside forces, so that you can have what we call sovereignty, right? Because if your sovereignty is, you know, dismantled by outside forces, it will always be easy to toy with. But at the same time, don't be too stiff, though, to not accept correction, because there's nothing wrong with that. Everyone gets it wrong sometimes. Even just because of a mistake, it doesn't mean that you wouldn't know or you couldn't figure it out. It just means you are wrong in the way you just executed it. And wrong is wrong, guys. You cannot make it anything else. It's just wrong. But we have better ways, of course, to showcase that somebody's wrong. We just say there's a mistake in there. This is the possibility. Isn't it fair? But in essence, we're just saying you're wrong. However nice we put it, it's just wrong. A spade is a spade, man. A spoon is a spoon. You cannot say it's the thing that scoops food from Euclidean. It is just a spoon. Okay, in the diagram, the graphs of f of x is equal to 2. Of course, guys, I'm not going to tell you this now because you should know it. You know what that means. And that together with this vertical shift, it shifts things around. So it already tells us that our maximum there is at 3, right? Because it's going to be 2 plus 1. Now, what would be the minimum here for this graph? Which literally coincides with the minimum of the other one. Hi, man. Yeah, this one. So that minimum coincides with the minimum of the other graph, as we can see. What should it be? Minus 2 plus 1 is going to be minus 1. So know these things, folks. If you don't, you're going to be dead. Of course, the maximum here is going to be just at 1. Okay. No manga business there. So know these things. Don't need an invitation for them. All right. Okay. All right. So now we have it nice and easy. So there has been an issue though. Right. For the cosine function, we know that we have a period of 360. So this is good. And if you look at this cosine function, you will appreciate that this must be the one, is it? Yeah. And I was going to be so excited if it wasn't labeled. But folks, we see something. Is the standard way. No, it's the standard way. So if we look here, this, although looks inverted, or should we say, yeah, inverted, This is minus 180 to 180. Can you see that's a period of 360? This is a full cosine cup looking the other way around. So that's the period of 360. So what do we expect? An x-intercept at 90. Ne? So we expected it at 90. So at 90, what do we get? We get 0. Times 2, that's 0. Plus 1, that's 1. So it means this x-intercept is not going to be at 90 anymore, because this graph has shifted a bit. So we shifted this graph a little bit, or maybe augmented it and shifted it, so everything is going to be slightly different. So let's just forget those ones. Let's focus on the minimum. Minimum is supposed to be at 180, right, for a cosine function. So minimum is going to be minus 1 times 2. It's minus 2 plus 1, that's minus 1. And we can see the minimum is right where it's supposed to be. Minimum is right where it's supposed to be. Okay, that's good. We're done for this graph. We're not going to worry about the intercepts for now, because they are going to challenge us a bit. We will need some calculation rather than the shifting of things, because it makes everything a bit horrible. So, but I would tell you that the best thing to think about this is that to kill this 2, so that we get minus 1, we should get minus a half here. When is it going to be? Minus a half is at 120. Right? Cos of 120 is minus a half. Times 2 is going to be minus 1. Minus 1 plus 1 is 0. So this means this is at 120 degrees. You can think about it that way. And of course, symmetry, this is going to be at minus 120 degrees as well. So, of course, this is just me thinking ahead. Of course, I'm just trying to demonstrate, folks, that these things, you don't need too much to deal with them. You just think about what possibilities would give me what I'm seeing. And you look at it, of course, before 120, before 180, that qualifies for 120. Because we know the first quadrant always goes up until wherever, but because of shifting and augmentation, things are going to shift a bit. But I would expect things to be there, right? And you can check it on the calculator and say 2 into cos of 120 plus 1. We get 0. So that's it. It wouldn't lie. All right, guys. Analysis completed. Let's get to the next one. This angle is doubled, so it means the period is essentially, maybe let's use a different color, because now it looks like I'm saying those things are equal, and they're not. So we have the period. This one completes a period in half the normal one. So we see that 180, we have a full sine wave, and that's it. Otherwise, nothing else changes. All right, so I drawn for this interval. Great. What it says, write down the range of f. Okay, range of f is going to come from the amplitude together with that shift. So if it says write down, we only expect the answer y. Range is equal to a set of y values such that y is less than or equal to 3, greater than or equal to minus 1. You can see the answer only, guys. Answer only. So no one cares about how you got it. So 7.3. Sorry, 0.2. Goodness, I'm too quick now, so I'm feeling a bit whacked. Write down the period of G. Again, the period is 180. As you can see, this is a full sine wave coming up at a full period A. So we know that this is 180 degrees. Again, another easy mark. 7.3. that I was obsessing about, I don't know why. For which values of x in this interval is f increasing? Of course, f is increasing from the minimum value all the way to the maximum value. and then after that it decreases from that maximum value to the minimum value. So of course we're not going to include that value there at 180, so we will write here that x must be less than 0 but greater than minus 180 degrees, because we don't include those since it's stationary. It's not increasing, it's not decreasing. So we just exclude those limits. Right. Not a big deal. So what else do we say? That was 1 mark 2. Hi guys, can you mean 7.4, use the graphs. Usually this is another question to come and relax on, except that there's always a nice question that comes out of it. Just one higher grade question. So be very ready for it. So use the graphs. See here, the instruction is clear. Use the graph. So whatever we do must be related to the graphs. Otherwise we'll be in trouble. To determine the values of x in this interval, for which g of x, now these are the y values of g, multiplied by f prime of x, this is gradients of f of g there. Now when we multiply this, we need to get a product that is negative. So this happens when we have a positive multiplied by negative, which is equal to a negative, or a negative multiplied by a positive, which is going to be a negative. Right, so we look at that and see what can we do. Okay, I don't need this. It was just for demonstrations. Oops. Okay, great. So gradients of f, these are positive gradients. At the, what you call, there it's equal to 0, equal to 0 at the turning points. It's 0 at the turning points. These ones are negative. Now let's look at g. Of course, g has positive gradients in between. They are 0 at the turning points, 0 at the turning points, and then these ones are negative and these ones are positive. Negative here in between, 0 at the turning points. Of course, here it's 0 as well. I mean, the gradients are negative here. Sorry, positive, sorry. So this is what we have. So again, guys, understand this, just assign stuff. Oh goodness, g, we're not looking at gradients. Okay, let's forget about g. We're not looking at it in terms of gradients, but in terms of y values. Okay. Right, so let's just use a different color. Evan, what did I just do now? Evan. Hey, now emakhamba. Wenza ntoni ngokusana sisiqhela. Okay. From here, the y values are 0, then they are positive. All the way. At the turning point, it's still positive, and then 0. And of course, positive there, then they are negative, negative at the turning point, negative, and then 0. Okay, negative, 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 0. Positive, 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 0. Okay, guys, so use a rough sketch here to get things going, because you need to be, or even a pencil. Now, this question looks simple, but it's one of those higher grade questions, I can tell you. You may want to skip this if you don't know, so that you don't waste time on it. This is just for 2 marks, but technical 2 marks. Now we can see that the gradients here is 0, so zeros are not included. So when this is at 180, we're not going to use it. because the product is 0. And when we are looking at 0 degrees, the product is 0. And when we're looking at 180, the product is 0. So these ones are excluded. Minus 180, 0, and 180. But now let's look in between. Here, the gradients are positive y values. So that's a positive answer. So this is out. But once we get here to this 0, okay, let me just show you. Okay, guys, so if we look at those intervals, of course, you may need to use a ruler and some different colors to be able to see this, or move with a ruler. So guess what? We have a positive gradient multiplied by positive y values. So that's a positive answer. So this interval we don't need. We get to when this is 0, right? Now once this happens, beyond this, the y values are negative while the gradients on the other one are still positive. It goes up until here. Negative times positive, so this satisfies this constraint. Good. And then we look at this one past this is positive y values multiplied by a negative gradient. So this is good because it's going to give us this setup. And it happens up until these ones are 0, so that product is not, so we can't take it. Between here we've got a negative gradient and negative y values, so that's not good. Beyond this line we will have negative gradients and negative y values. Again, this is out. So basically it's those two intervals. So we can combine them into one single interval, if we like, with a restriction. So another student may just want to write here that x must be less than, wow, we forgot this one. What should be the value here? Okay, this would be the intercept. So the intercept is at 180, but half of that is 90. So we're going to have it at 90 degrees. Right? So that would be 90 degrees. So this must be less than 90 degrees, but greater than. Again, we look at this x-intercept right here. What should it be? Well, this should be minus 180, but then if we divide that by 2, it becomes minus 90. So this is minus 90 degrees. Great. Because the angle is doubled, isn't it? Yeah, boy, yes. Now, we can make an exception here that says x must not be equal to 0 degrees. Because at 0, the gradient is 0. So that product becomes 0, so it's not less than 0. So we should not have this. So this is 1 mark, and that is 1 mark. Or, another student may want to write it this way. Say x must be less than, what is this value right here? 0 degrees, but greater than minus 90 degrees. Or x must be less than 90 degrees, but greater than 0 degrees. Okay, that is how one could write the same answer. Not a big deal otherwise. So even the interval notation can be entertained here. But whatever, guys, whatever. The 2 marks are in the bag. Now this was not an easy question, of course. So this is 7.4.1. Oh. Okay, let's move it down. Okay, so this is going to be 7.4, this is 0.1, 7.4.2. Now we need to solve this for this to be less than a half. Of course, we manipulate this, cross multiply the 2 is a positive 2 cos x, and then we transpose 1, it's going to be plus 1 less than or equal to 0. So if we sort this out, we can clearly see this is the graph of f less than 0. So when is the graph of f less than 0? From this 120 to minus 180, and from this 120 to to 180. So this is where f is negative. Okay, we see that this is here. It starts being negative from that and there. Alright, so we can handle it. So we can just first sort up this and say cos x less than minus a half. Okay, this implies cross multiply that 2 cos x is less than or equal to minus 1. Remember, the sign doesn't change. 2 is a positive number. Perhaps we might want to show this and say we're cross multiplying. So here we're multiplying by positive values. This is positive and this is positive, so the inequality is not affected. Then we transpose. Therefore this implies that we've got 2 cos x plus 1 less than or equal to 0. So this therefore tells us that we're dealing with f of x must be less than or equal to 0. So examiners here are playing tricks on you, and you need to be up to the task. Maybe let's just say this is an implication. So we can say therefore this happens when x is less than that x-intercept here minus 120. Can you see working out those x-intercepts was good, but this must be greater than or equal to. Remember, this one is included. In fact, this one is also included because 0 is included there. At minus 120, f is 0. So yeah, be very careful of how we write answers here, guys. Or x must be less than or equal to 180 degrees. It's included. So greater than or equal to 120 degrees. Nice. So that's it. That's it. So basically we're getting the marks for this value, that value, these two values, minus and plus 120, because we needed to think about them, and the rest of it all. Hi guys, this is crazy. Even this simplification, sometimes I feel it matters. So I'd say this side, that side, and perhaps the gymnastics that simplify this to something meaningful. Because if we're told to use the graph, we need to make sure we have the graph somewhere. So that's 3 marks. Okay, that's easy. Okay, not too easy, of course, for others who don't pay attention, because you guys expect to see what you have seen already. Remember, what you have seen is just for you to practice on, so that you are better and more aware. Okay, now it says the graph of G shifted 45 degrees. Shifted, that's a translation, to the right. Okay, to obtain a new graph of h, determine the equation of h in its simplest form. Okay, again, this is one of those higher grade questions, which is a mild form of higher grade. It would fit both standard and higher grade. So first of all, we know that h of x is going to be equal to g of x. Now shifted to the right is going to be minus 45 degrees within the equation. So this is the message to us. This implies that h of x is equal to, what is g of x? G of x is sine of 2. Remember, x is going to be replaced by x minus 45 degrees. Right. This implies that h of x is equal to, now this one is going to be sine of, we distribute the 2, it's going to be 2x minus 90 degrees. Great. Now, cofunctions kick in. Therefore, h of x is going to be equal to, now remember, minus 90, this is the fourth quadrant, right? Right. Or one can take out a negative and put it in front of the angle. So sine of a negative angle is going to be minus. So this is minus sine 2x. Basically, minus sine 2x. That's the graph of h. So what does it look like? It looks like essentially a vertical reflection of this function. No man, don't lie. Cofunctions, this is cos. Wow. So basibalexeleko mfana wam, sibalexeleko. No. Minus cos 2x. Okay, that's good. That's good. If you want to think about this one, you can just easily draw the Cartesian plane. And now this is minus 90 degrees. Now when we're adding x, we're moving in this direction. So we are adding 2x, which is that angle. We're adding it like that. So sine in the fourth quadrant, negative. So that means its cofunction should be negative, because we follow the original function here to decide the sign. All right. Or any other means necessary, of course. Some people choose to factor out a negative. Sine of a negative angle is minus sine. Now it's going to be 90 minus 2x, which goes to cos 2x. Good. Easy. Now, what is the story here? 2 marks. Of course, using cofunctions here. Nice and dandy. Here, I think writing the rule in a substituted format is key, I guess. Yeah, there's a lot of areas, but it's just 2 marks. Of course, this one is scored. So this is now 10 easy marks. Okay, these ones were not so difficult at all. If you understood what to do, we just go with the flow. All right, some questions, you look at the marks, guys, you don't want to start showing some hectic calculations, just assign values. Knowing though in the background, you could justify it by a proper calculation. This was an answer. Shouldn't leave answers floating. To show that the answer has been reached, we must see it underlined. Same as here if we gave it like that. Okay, but of course answers where there's no calculation, it's good enough to leave it flying. But when there's a calculation, you need to show that there was an end to this. Of course, guys, whatever, man. Maybe for this, it's not necessary to underline, just to write it. But whenever we had some steps, we need to show that there's an end. We're closing. This is called closing the step. But remember, we don't close an argument. Or in fact, we can call it a mathematical full stop. It means it's an end. So we only end a sentence at its end, right? We don't end in the middle. In the middle, we can use commas if we break it up into parts, or semicolons and colons. But at the very end, we put a, did I say a comma? No. A full stop. A dot. This is a mathematical dot. Because in maths, a dot means multiplication. So please, don't use a dot for an end. A dot is for multiplication in a mathematical expression. At least in our level. So don't go confusing us here by putting things that don't make sense in terms of our mathematical knowledge. So let's just say from grade 1 until grade 12, just know a dot in maths is multiplication. It's not used as a comma. Never see it If you see a dot, you know you're seeing multiplication in maths. Okay? Except at the end of a clear English sentence. That's a different story. Okay? But anyway, in a mathematical expression, a dot represents multiplication. Right? Right. And the end of a calculation would be perhaps an end of a sentence of some sort. We expect a dot, but now this is a mathematical dot. Yeah. But again, I don't know, man. Different teachers emphasize different things in a different way. Yo guys, because I'm looking at the time. Question 8. (3D) structure. In the diagram, ABC lie on the same horizontal plane, nicely shaded. AB is equal to AC. AB is equal to AC indicated already. Okay, that's an isosceles triangle. If that is X, this should also be X. Okay, angles opposite equal sides in triangle ABC. Now D is directly above. The word directly means 90 degrees. Again, it's already indicated above A. Sometimes if it is not shown, you show it. Such that 2 times AD is equal to BC. Okay. Now this is very good because it will provide us to calculating things. Now also AD is equal to P. Okay. Now ABC is X, we can see it, and then DBA is Y. So that's good, all indicated. So we don't need to really show anything, just whack everything. We need to determine AB in terms of P and Y. So what does that mean? We need to use this triangle. So that's the triangle we need to work on. So this is 8.1 in triangle ABD. The abbreviation of abdomen for those who are surgeons. ABD. Even the swabs that we use to, use to dab inside the abdomen, we call them ABD swabs, abdominal swabs. Surgeons or surgeons. Which one is the one? Okay guys, the right angled triangle, we don't need a lot. So this is gonna be 10. Because if we want AB, we have the opposite, we have the angle, so we've got the adjacent. So this is 10. 10 of Y is equal to opposite P over adjacent AB. Now this is over 1, cross multiply and divide. So we will see that AB is going to be P over 10Y. Okay, so that's it. Nice and easy. So 2 marks really for the definition and the final answer. I guess 8.2. We need to show that cos x is equal to 10y. Okay, that's a bit. So for sure this one must be one of those higher grade versus standard or in between. Let's see. Cos x ungenapi. Cos x ungenapi. Yo. Of course, if we're saying BC is equal to 2 times AD, so this means this is 2P. Okay. Now, this looks like we are doing a cosine rule here, the way I see it. Ne? We're doing the cosine rule. we're doing the cosine rule. So this is good. So we're going to be moving into this triangle, and this forces us to work out this angle, which is going to be 180 degrees minus 2x, isn't it? From 3 angles of a triangle. But now we've got cos x instead of cos 2x, because this will simplify to cos 2x. So I'm feeling a little bit unhappy, but I don't have anything. What about sine rule? So sine this over that, sine that, maybe sine this over this. Maybe it might work rather than the cosine rule, because the cosine rule is going to complicate our lives here. We're going to need a lot of simplification. So maybe we can choose the sine rule. Maybe let's opt for the sine rule and see where it lands us. All right, so what are we going to say? We will say in triangle ABC. Okay, what do we want to say? Well, we know that basically sine of this angle ABC, which is x. Perhaps let's just try and use this one, sine ABC over the side opposite that, which is going to be, but since we did AB, I would rather we use this angle instead, the other one. Okay, it's not a big deal. Over, say AC is equal to sine of BAC, or yeah, let's just call it BAC over the opposite side, which is BC. This is the sine rule. All right, so this implies that we've got sine of x divided by AC is what we have there. So this is just P over 10y. Substitutions, guys. AC and BC are equal, so we don't need to justify this. Equal to sine of BAC. This is going to be sine of 180 degrees minus 2x all over BC, which is 2p. Remember that equation. Okay, this one is one of those silly questions, so we may want to deal with this. This is sine x divided by p over 10y. Try to simplify things in a manner that helps you. So this simplifies to sine 2x using reduction formulae over 2p. So this also implies that this becomes sine x times 10y over p equals sine 2x over 2p. Okay, so we already have 10y, and we can see this is going to work us right into what we need. So this also implies, now what I would like to do is to just expand here. We've got sine x times 10y over p is equal to 2 sine x cos x over 2p. Now our job, guys, is to isolate cos x here. Now to do this, we first cross multiply and then divide. So this implies that cos of x is going to be equal to, when you multiply there, it's going to be 2 sine x, 2p times sine x, oops, where is the cos coming from now? 10y divided by, now we divide by this issue there. It's going to be also 2p, because p times 2 is going to be 2p, right? This time we're going to divide by 2p sine x, ne? Yeah, that's what we're going to divide by after we have done the cross multiplication. So this divides to 1, and that divides to 1, and our answer comes out nicely. Therefore, indeed, cos x is equal to the tangent of y. All right, not so bad, not so bad. Now, I don't know how these 4 marks, guys, are scored, but I know this one for sure. And when we use the reduction formulae, for sure. Maybe calculating this angle, for sure. The rest of these gymnastics, honestly speaking, don't matter. Cross multiplication is your problem. This whole substitution business, maybe this is significant, but I would suppose writing the rule properly, the general substitutions, the rule, I would gravitate towards that. Okay. Now, last question, 8.3. Says we need to, if x is 60 degrees, we need to calculate the size of y. That's easy, guys. So we know that cos 60 degrees is going to be equal to 10y. Now, this implies that 10y is a half from special angles. And we can say safely, therefore, y is going to be equal to the arctan of 0,5, which is going to give us what? So we say arctan 0,5 is 26. Remember this angle, we've been dealing with it in the analytical geometry. Now we're going to do 5/7 degrees to 2 decimal places. So can you see the examiners are just holding on to this 26, some change degrees. So, yeah. Analytical geometry here helps us to remember our things. So, obviously, folks, substitutions and the answer. Very important. I didn't want to write the rule first, but it's a matter of doing it. You know, it's a matter of doing it, but I just ran out of space. So all you would do is to write here cos x is equal to 10y. Whatever the x value is going to affect 10y. Okay, good. That's it. 8 easy marks here. Maybe the one, but this fits both standard and higher grade, so I wouldn't call it a higher order question. Now let's get to question 9. Question 9. In the diagram, triangle DEF, the big one, is drawn. Line GH intersects DF and EF at G and H respectively. So there it is, such that GH is parallel to DE and GF is 2DG. It's going to be 2 over 5. So this is 2A, 5A. Remember, this is not an actual value, so we need to choose some multiple, because it is the empiric formula, basically, not necessarily the molecular formula. if you understand what I'm talking about. If you don't, well, goodbye. Thank you very much. So we've got 9.1 with 9.1.1. So I write down with reasons the value of HF. So we want HF over EH. Okay, so this is the proportionality theorem right here. So we know that HF over EH should be equal to GF over DG. Or is it what? Yeah, DG. Now we need a reason. This is the prop theorem with, what is this? GH parallel to DE in triangle DEF. Okay, of course one could have said in triangle so and so. This is the case, proportionality theorem, but now since we didn't speak about in, we need to specify what we are talking about. So we conclude therefore HF over EH is equal to 2 over 3. So this means this is going to be 2y over 3y. We need to choose a multiple there and put it down. Of course, guys, the question said write down. So what is the best argument here? This is ridiculous, in my opinion. It's absolutely ridiculous. So it means this is to be neglected. Wow. But for me, because usually if someone says write down the value, we don't want to see this. Although this translates to this, but we would rather we see this there and this reason. So this is how you do it. Although you know this is how it is, unfortunately the examiner is saying things that sometimes don't make sense to do it that way, because you can't say write down the value, because now we're going to have a reason that is flying. What is this? It is that other one. Okay, how does it relate? You see this? Okay, anyway, whatever, guys. So it looks like the examiner has this in mind, and that's it. If you didn't see it, then you did not. Unfortunately, we follow instructions, folks, religiously. If not, we lose marks. Now, if EF is 21 centimeters, we need to calculate the EH. Okay, that's good. So EF, what is this now? EF, okay. EF, the entire length here, is, okay, let's rewrite this 2y here. So if this is essentially 21 centimeters, now we need EH. So EH occupies 3 parts of how many parts? 5 parts, because 3 plus 2 is 5. Then we multiply by the value that it is. Okay, so we can say therefore EH is going to be what we get over there. So this is 21 times 3 divided by 5. So this is 12.6 centimeters. Okay. Of course, one could do it, another way. Say EH over the entire EF. So you can just write EH over the entire EF should be equal to, we can choose anyone. I mean, the side that corresponds with that is going to be dg over df. Right, again, proportionality theorem, wara wara. Then EH is what we want over EF, which is 21. DG, this is 5A over the entire thing is going to be 7A. Right. So the A's do us the honors, so this means EH is going to be 5 over 7 times 21. What is that? So 5 times 21 divided by 7. I'm getting 15. Now that means I performed a crime. Ah, goodness, where did I end up with a 3 now? Ish, this guy. Remember, this is 2 over 5. My lord. Yes, this is bad. See, sometimes trying out something, this is what happens then in the exam. You find that your first attempt was somewhat wrong, so this should be 2 over 5. So that's what this should be. So can you see, thinking of it another way uncovers the mistake. I often do this all the time. So if you answered something, to check it, try another way that you know is valid, you can handle. You will see that you made a mistake. So first and foremost, this ratio is wrong. So this should be over 5. Okay. Now we get our marks. Otherwise we would have lost easy 4 marks here. So of course, this means this occupies 5 parts of how many? 7 parts. And this becomes 15 centimeters. Okay, so now this works out nicely. Because even if we use this, it will still give us the 15. Even if we use this, it gives us the 15. We made a mistake in our substitutions and we run a risk of losing out. So sometimes checking things helps, guys. As you can see, when you start to feel tired, you start to make errors. Very easy ones. Very simple errors. So let's see, 9.1.3. We need to write down a triangle which is similar to triangle FGH. So it's going to be the big one. It's going to be FDE or DEF. So it's triangle DEF. Nobody said we must provide a reason. I mean, this one is like a standard grade. In fact, a lower grade question. Because there's nothing in there. But it's already a clue that to solve the next question, we probably are going to need similarity. But if you understand this, you know what to do. Hence, calculate GH over DE. That's good. So this one is going to require us to use the proportionality theorem using similarity of these two triangles. So this means GH or okay, look, we don't have we don't know that size. So if we don't know that size, we don't need it because we need something that has a size. So we're going to choose this size because of this 21 centimeters. Ne? But now this will force us to finding out this 2y. What is it? Of course, if this is 15 from 21, we will know what 2y is. So it's not a big deal. So we're going to say, well, HF over HF over this GH, or whatever HG is, this GH must be equal to, remember this is the side of this triangle that we spoke about, then it's going to be this whole side of the other one over that side. So it's going to be EF not GF, oops, EF over ED or DE. Okay, so we need to finish erasing. This is the prop theorem with HG, or in fact sometimes we can say similar triangles, whatever we want to say. For me, this is still proportionality theorem, which HG parallel to DE in triangle DEF. Proportionality theorem and similarity is more or less the same thing. So we say this implies HF, we know that this is going to be 21 minus 15, right, over GH. Now we calculated the size, we did not. GH is what we want in the ratio, okay, equals EF is given as 21 divided by DE, which is what we want in the thingies. Now, what do we do, guys? We just cross multiply and divide. Can you see this? But now this is not going to give us what we want, okay? It's going to give us what we want. We're going to cross multiply first. GH times 21, we're going to get 21 GH equals, this one is 21 minus 15. Yo, this calculator is making noise. This is 6 DE. Okay. So what do we need? We can divide by whatever we want. So since we want DE on the denominator and 21 out, we're going to divide by 21 times DE. In math, we can divide by whatever we want as long as it eliminates what we want to eliminate. So we know that DE divides DE to 1 and 21 divides 21 to 1. Those things are invisible. So therefore GH over DE is going to be 6 over 21. Okay, that's it. That's it. Nice and easy. But this for 2 marks, folks. Wow. Wow. I don't like it. It means this calculation, because it's it. And the final answer. But guys, what about the rules? This is Euclidean geometry. Are you kidding me? Alright guys, no man, no man, no man. I don't like this. So it means statement and reason and the final answer. No one cares about that calculation. Maybe it's too obvious, but 3 marks would have been fair, guys, to stop the arguments. Again, this is what happens when you award marks where they don't need to be awarded. Okay? Alright, okay. Like this question. This question is ridiculous, in my opinion. You cannot give too many clues. Let the students suffer, guys, if they have to. Because look, now you're squeezing the mark that is useful by trading the clue. Maybe it's okay. Maybe it's okay. Let me not complain too much, but I feel like I should complain. But again, the examiner is saying, look, I traded you a clue, so I'm going to take 1 mark for myself for giving you this clue. Okay, it's okay. We accept. So that's easy, 2 marks, folks. Let's go to 9.2. It's a pity, guys, our question paper is not complete, so we don't have that gymnastic part, you know, the suplexity. Guys, why did you squeeze the suplexity out? Maybe there's a problem with that question, I guess. I don't understand why. Okay, in the diagram, POL is a diameter. So POL, of course, any straight line from circumference through the center to circumference is a diameter. Again, too much generosity here. This tells us we have 90 degrees there. Angle in the semicircle. Now of the larger circle with center O, again, you know that. Nice. So TMR is a diameter of the smaller circle. So TMR, if this is the case, then this is 90 degrees too. Angle in the semicircle. All right. So this is also good with that center M, I suppose, yes. Now the two circles intersect at L and R, okay. PLK is a tangent to the smaller circle at L. Okay. PLK is a tangent to the smaller circle at L. So what do we see there? Well, we've got a 10-chord theorem situation here. This angle is equal to that, with that angle equal to that. That's what we can say so far. Okay. Great. So, and we're told also TR is a tangent to the larger circle. TR is a tangent to the larger circle at R. Okay. Great. So this angle must be equal to that 10-chord theorem. All right. So, cool. OM intersects the smaller circle at N. Okay. Not a problem. This means it's a straight line. That's what this means. Straight lines LT, LN are drawn. Okay, good. So what can we say? Obvious. This angle L1 is equal to angle P. Those are corresponding angles. So these lines must be parallel. Of course, this is a deduction. We will need to justify this if we say it. Nice. Now what can we say? Of course, we could have looked at this too. This is 90 degrees, that is 90 degrees, so they are equal. These are alternate angles. Even if these lines are not parallel, these are alternate angles. But when they are equal, it means the lines must be parallel. So we could have deduced this from just those two without that piece. And from that piece, we could then say what we have to say. Okay? We could be asked to prove that this is a tangent, in fact. Could make this question tougher. Say, prove this is a tangent and not state this. So one could say this is equal to that. Then these two lines are parallel. If these two lines are parallel, it means this angle is equal to that. Ne? But this angle is also equal to this 10-chord theorem in the smaller circle. Therefore, this one is equal to that. Therefore, this becomes a tangent. You see that? You see that? We could complicate it, but let's not complicate it now because nobody did. What else can we say, guys? We know that these are ready, right? So these are ready. They are equal. Can you see when we have a quadrilateral like this and the point joining the two midpoints? Konje, what do we call that? Is there something like that? Maybe I'm trying too hard. I want to say this line is going to be parallel to these other ones. Is it? Let's not say anything. Let's leave it at that, okay? 9.2.1 says, we need to prove that LT is parallel to PR. 4 marks. Really, guys? Okay, we saw it anyway. Of course, it wasn't too clear. Angles in the semicircle or the corresponding angles, it depends on how you see it. So we will say, well, we understand that R2 is equal to 90 degrees. Why? This is the angle in the semicircle. All right. Also, we understand that L2, angle L2 is also 90 degrees. Again, angle in the semicircle. So therefore, these two angles are equal. Each is 90 degrees. Therefore, remember these are alternate angles. So when they are equal, it means the lines are parallel. So we can say therefore LT is parallel to PR. We can say here alternate angles are equal. So when alternate angles are equal, it means the lines cut by a transversal are parallel. Let's stop it there. So this is a mark. This is a mark. This is a mark. And perhaps the extra mark is stating this too. But of course, one can use the corresponding angles and say this and that 10 chord, this and that 10 chord, therefore this and that are equal, corresponding angles, then conclude the parallelity. Either way, it's done. 9.2.2. We need to prove that LORM is a cyclic quad. Where is it? So basically, this LORM is this bow tie situation. So if we can prove angles in the same segment to be equal, we are winners. You see, I knew this thing was coming in, guys. How do we explain this business right here? We have a problem, right? Right, because, yikes, this one, I don't remember this thing now, but I would make it a higher grade question because we actually could, if we prove this OM is parallel to LT, it means this angle is equal to that, while this one is equal to that. So this means angles in the same segment would be equal, or this angle is equal to that. How? By saying this is equal to that, corresponding angles, and then this being that, so those are angles in the same segment. So now how do we then justify this being, whatever this is? Yeah, doch, this is where it hurts, isn't it? It hurts. Because I was thinking a quadrilateral, if we've got those lines parallel and then we're joining the midpoints, it means this line must be parallel to either one of them, isn't it? In a quadrilateral. Provided these two sides are parallel, of course. These two are parallel and then we're joining the midpoints. That line should also be parallel to the others. Or is there any other explanation for this? Because I do not see it. So I suppose we should make that a situation. Or ayike nesikhulule ke ngo. Ayike basikhulule. So if it is also given that LT is parallel to OM, ayike nesiqibile. I was still thinking if this is good, but of course think about it. If you did not get given this, you would have to, of course, now this solves our pain. I say standard grade question. I shall qualify as a higher grade anymore. Alright, so guys, this is now easy because we will say simply what are we supposed to prove? That this is cyclic quad, so we can choose which angles we want to use. So since we spoke about, okay, we didn't speak about these others anyway, so we can choose either one of them. What can we say? We will say first and foremost, we know that O1 is equal to angle L1. These are corresponding angles with OM parallel to LT. Right. So those two are equal. We've got a statement again to make and say, but We know that angle L1 is equal to angle R1. Why is this? This is the 10 chord theorem. Okay, we don't need to say anything. In the smaller circle, 10 chord theorem. So what are we concluding? Therefore, we know that O1 is equal to L1. R1. Because each is equal to angle L1. Therefore, we can say this is LORM is a cyclic quad. Now we proved angles in the same segment, so we're going to say converse of angles in the same segment. Alright, so this is easy. I don't know why 5 marks here. Honestly speaking, with so much given, see, this is why I don't understand certain rationales, because there's no rationale in there. So this is a mark, perhaps 2 marks here, I suppose, and maybe 2 marks for the answer. Wow, guys, this is ridiculous. But you know how these ones usually mark this? They would say here, statement and reason, statement and reason, and then reason for the conclusion. Okay, that's fair enough, but wow, creating the impression that this is a difficult question when it's not. Now we need to prove that Ln bisects OLR. Okay, where is Ln? Oh, it's this small line right here. We need to prove that this line bisects this angle OLR. So it means we need to prove that this is equal to that. Okay. We need to prove that that is the case. All right. 4 marks. What must we say? Well, using the angle at center story, for the small circle, we see that M1 is equal to that whole angle, this thing. But M1 is 2 times this dude. Angle at center, 2 times angle at circumference. That can work. Right? Right. That can work. But I'm trying to see what the hell. But we can use the angle at center to link this up. Let me see if it doesn't create a nice equation. We will say, well, M1 is equal to 2 times L3. Right. Why? This is the angle. Center equals to 2 times angle at circumference. For the arc NR on the smaller circle. We've got a story here, but we understand that M1 is equal to L4 plus L3. Right. Now these are angles in the same segment. For cyclic quad, whatever, we can say LORM is a cyclic quad. Just so that no one understands us wrongly and say where these angles we're talking about. Let's say the memorandum chose a different approach. Remember, guys, don't be fooled by the memo. It was written by those who created this question. But you did not create the memo. You didn't even create these questions. You only respond. So respond adequately. So that whatever happens in the memo, someone who's marking it doesn't give you or victimize you because you are not clear enough. Okay, especially if this approach is not there in the memo. Sometimes it may not be there. So think about that possibility. So when answering, try to be very nice. So this implies, perhaps I can just go and say then, then we understand that M1 is L4 plus L3 is going to be equal to 2 times L3, right? We just substitute M1 with that. Yes, it provides me a nice equation because when we transpose L3 to its like, it's going to be subtracted. So we can say, therefore, L3 is equal to L4. Therefore, I don't know why I wrote implies and therefore. Therefore, we can conclude that Ln bisects OLR. Because that's it. Okay, very nice one, very nice one. So of course, marks this proof right there is key. Maybe one of the statements deserves more, but perhaps substitutions. Sometimes you cannot ignore them too much. So that makes up 4 marks, nice and easy. So that was a very nice 20 marks. Okay, not too difficult. Intermediate questions, honestly speaking. And then of course, guys, we don't have the suplexity that was going to make us cry, which definitely should make us cry. I don't know why the person who uploaded this thing scanned up until question 9 and then scanned this thing without question 10. What happened? Unless there was a problem. So those who wrote will know what happened. If there's nothing that happened, but somebody decided to not put that question here, please show us. Let us see where the problem might be, if there is a questionability about it, so we can uncover that secret. Remember, we are like the secret, or is it what, private investigators. We come up with answers that normal investigators would not bring up, okay? So we sniff everywhere. Anyway, guys, I hope you enjoyed the review. Don't worry about some of the things I say. If they rub you wrong, just forgive the guy because it's not intended to do so. If they rub you right, well, laugh along with me because it's meant to be a joke at times. But of course, there are some serious points that we need to highlight, whether it hurts or doesn't. And you just have to deal with the truth, or just go and comfort yourself with what we call a delusion. Because for me to believe things that are not realistic and not face reality is delusional. Anyway, anyhow, it is what it is, guys. We call a spade, and we're not gonna call it the thing that is used to, dig into the ground or something. There's too many things that are used. So which one are you talking about? Uthatha nge-boss pig, khona ipegi phela, i-boss peg. Yabona? Nekhuba liyayenza lonto, which is a hoe. Not the one that you guys think about when I say hoe. I don't speak profanity. Trust me, I do not. Even when I curse you nicely. Believe me, I do it like that. So I curse you nicely without using profanity. I do not use profanity, okay? Maybe I did sometimes, but maybe the milder forms. I would never use, the higher grade forms of profanity. Okay, please don't be profane in your language. Run away from it. Anyhow, the hoe, ikhuba. Now ikhuba zindidi ezimbini, khona letrekele, right? Kube khona elitsalwa zinkabi eliyi-1. Kube khona elokuhlakula, kukuleli phuthetha ngale. Ibona lento uba ingaba ingxaki enkulu xa vele uthethe nje singakuve uthetha nantoni. Kodwa xa uthetha sikuve, ngoba lento othetha ngayo uyayikhomba uba nantsiya. Ndiyacinga uba akhathaliseki uba omnye umuntu uziva njani xa uthetha ngenyani, ngoba uzawuqunjiswa yinto oyithethayo kunoba aqunjiswe yinto akacingi uba uyayithetha. Yayiva ke ngoku le nto ndiye ndiyithande phaya le nto uba umntu ungcono sikakwenyanyele inyaniso kunoba kwenyanye ngenxa bengakuvisisisi. Yayiva ke ngoku. Basically, in English, I'm trying to say it's easier and better when someone hates you for exactly what you are saying, if that offends them, rather than to think you are saying it and yet you are not, because you are not so clear, you were quite vague. So you will end up being hated wrongly so. Okay, so rather be hated for what is right and true than to be loved for what is wrong and untrue, because when that comes out at the end, you stand to lose a lot more credibility than you would if you just faced the truth earlier on. Okay, you may suffer a loss. Yes, the truth hurts sometimes. You suffer a bit of a loss. Like I'm saying, if I'm telling something that is true and somebody is rubbed wrong and they don't like it, mind you, I will only be hated by that individual only. The others, they know and see the truth, so they have no reason to hate. Even if they love that individual, they'll be like, oh wow. But if I tell or at least support a lie, and everyone believes in me, because guess what? The loved individual who was lying in the process is also feeling good, and everybody feels good. Later on, when somebody uncovers it, remember my reputation, my respectability, or should we say my worthiness of respect and trust, is going to be broken, because we'll be wondering how many things I am lying about, how many things I'm dishonest about. So this means one simple truth that gets uncovered as a lie in me could discredit my life's worth of work. And that's not good. Okay, that's not good, because in the future, everything that you are and stand for matters more than it does today. Believe me this. Let me make you an example. We are done anyway, so you can cry and run away if you don't want to hear this rant. But I take this opportunity to also chat to the listener in a way, because guess what? I'm all alone right now talking to the screen. But it's funny that you are listening and I'm talking to you. So let me show you why what matters a little now actually matters more in the future. Let's say you are a surgeon, for example. Let's take the more aggressive types, neurosurgeon, okay, because I have a special interest for that. For now, it's still an interest, it's not yet a thing. Let's say neurosurgery, you operate on someone, you make a mistake, somebody is disabled, okay? Not dead, disabled because of a mistake you made. And you own up, you cover that mistake, you lie and say this was expected, because yes, some complications are expected, but let's say this one was a complete lie. Because let's say you cut or burned an artery that you were supposed to protect. Remember, sometimes a brain tumor can have a lot of arteries passing through the tumor or near the tumor or pressed by the tumor, but they don't really get supplied by those blood vessels. So this means during surgery, you need to spare those blood vessels. Sometimes you get a blood vessel that terminates right into the tumor. This means it's a feeding artery, because terminating or blocking that artery is definitely going to assist in reducing the bleeding during the tumor surgery, right? Now, the other artery that can be associated with the tumor to some extent is the one that we call an end passage, meaning as it passes, it supplies but it's not the main supplier. But you see, sometimes you're not a parent to somebody's child, but as you pass through those children, if you've got sweets in your pocket, why not throw the sweets at the kids so that they can enjoy themselves? But guess what? It's not your responsibility to give them sweets. So this is more like that. We call it an artery end passage. As it passes, it leaves some branches. Now this means here you need to be very careful, because this artery is supplying mainly a different structure than the tumor. So when you resect the tumor, you need to cut only the supply from that artery, but the main stem must be left alone. Now this means, guys, you need to study the images, the CT scans, you need to do angiograms. Of course, we have what we call a CT angio, an MRI angiogram. This can help, because these are minimally invasive. There's a contrast injected, but it's not as hectic as doing a formal angiogram. We call it DSA, which is the best, by the way. Now, if you didn't do these studies, you will mess up that tumor surgery, because it will bend arteries you're not supposed to bend, you will cut arteries you're not supposed to bend. And of course, we said there's transit arteries. Did I mention them? I don't remember. Transit arteries are just moving through the tumor, but they don't supply the tumor at any point or at any level. So this means those arteries are not to be tampered with. So one has to be very accurate in these things. So this is why I'm choosing this example, guys, because it's high tech. A lot of detail needs to be paid attention to, as you would see with these questions. If you don't pay attention to detail, you're not going to make it. Now, say you're a careless surgeon, see a tumor there, it's accessible, maybe it looks like a meningioma, it's on the convexity, I can take it out. Of course, it's usually those sellouts type of tumors, because they make you believe this is easy to do, and then you see a disaster at surgery. So you go for it, and then somebody's disabled, and then you don't tell the truth that, hey, during surgery, mistakenly, I burned a transit artery, or I interrupted an end passage artery. And that's why you have a stroke now. Maybe you can't use your leg if one takes down perhaps the anterior cerebral artery. If the meningioma is parasagittal, let's imagine it is seated there. And you know what? If you owned up to that, that disability, remember arteries do recruit sometimes. It depends on the extent of damage that you caused, because remember these ones, they come from back and front sometimes. So some branches may actually somewhat supply, but not enough. So the weakness might just last a week. You give physiotherapy, within 2 weeks that weakness is gone, or at least it's better. Because it may not really go back to the original, but it may be better. But if a patient understands that, of course, you cost them a bit, but not too much. But you see, you spared their life from a disastrous tumor. If it grew, it would attach to the superior sagittal sinus, cause more damage and more difficulty with surgery. So they would have a life of a disaster, because guess what? That leg would go eventually as the tumor encroaches into, the paracentral lobule, which controls your leg. So in any case, this mistake was not too bad compared to what would have happened if the tumor grew and grew and grew and invaded structures there. But now you lie about it and pretend that, it was going to happen. Okay. But now, say 10 years down the line, you are now an experienced surgeon. Right. And then you commit one silly mistake. This time, let's say not necessarily a mistake you would call, but perhaps a blunder happens that is probably beyond your control, and perhaps somebody who's better than you gets involved and uncovers that and maybe calls it a mistake or calls it negligence on your part. Because at times you may find that you may have been told by that individual, please don't do this, do that, and then you disagree because you're like, come on, man, I know enough. Maybe you're a junior even. Maybe I'm 10 years in, you are 5 years in, so I cannot listen to you. You should be listening to me. This is what happens to people sometimes. Just an honest mistake of disregarding counsel. You run into a disaster. But guess what? It will then go back to this case that, wow, this guy, Mind you, when an investigation is started, they will go back into those images and they will see, wow. And usually in private, I don't know in government hospitals, but in private, usually, when you operate, you want to keep videos of what you did so that if someone takes you to court, everything is out there. So the microscope actually has a function that you can actually record the surgery so that one can see. Now imagine you will have done that too. Now if somebody looks there, then they will see, wow, what a wow, you bend this artery, and one can see that on the images, and then they can see you bending it. You are done, okay? You lose your license sometimes. Guess what? You will be called a killer, because if the case that illuminates all of these other small errors you've done and covered for without owning up to those mistakes, it makes you look dishonest because it looks like a series of lies. Then you may end up losing your license. If not, you're going to lose those cases. Imagine your life's worth goes to pay medical insurance. Even medical insurance that you take might be exhausted. You find that there's like 10 cases eventually that end up becoming a nightmare for you. So accept defeat when you are defeated. Please do it graciously or gracefully. Don't go around lying. Tell the truth. Because it may just be a minor loss that the patient may still recover from. Then in the future, when someone wants to bury you on just one single mistake because of envy sometimes, or spite, whatever, they will not win because you will have a track record of being honest anyway. So that would also be looked at in that same light. And guess what? They will find that this is an honest mistake even there. Or something that anybody could run into. And as an end, case dismissed. See? So guys, I'm telling you, small things matter the most when you don't need them. So try to be honest with even small things so that we can trust you with bigger things. Even when you show up erratic at some point, we need to still trust you because we see your track record. But if your track record is dishonesty, we will not be very friendly at that very end when you really do not need that, because you will never bounce back from that the same way you would right now. Even if someone was to drag you to court, it's just one case. Medical insurance could take care of that, even if you lose that case. But you will be so awake and you will sharpen your skills, you would not necessarily be dismissed because it's just one incident. Although you would be under a bit of a watchful eye of some people, but you would not necessarily be, chucked out of the role. But hey, this is me just sharing some things, guys, that sometimes you guys overlook, and we learn this from these little questions of maths, but they actually go far in how we live our lives and what happens to us when things go wrong. I hope you guys enjoyed the video. I will see you some other time. Sadly, I don't have the last question. Please, if you have it, share it with me. You have my email address on the channel. You've got my WhatsApp number. You can use any one of the two, please. I'd love to see what was in that soup-like city, because there's always a soup-like city. Whether you like it or not, it's always there. And I love that. I love those questions, because those are the questions that are typical of the questions we did. Higher grade stuff. All right, so we're always aware of some challenges somewhere. Anyway, guys, I'm going to talk until Jesus comes. Before he comes, let me finish. Thank you very much, comrades, for putting up with me in this long narrative here. And of course, a lot of ridiculous comments as well. Please see them as such. Otherwise, you will get palpitations for no reason. But most of the stuff, guys, is what I expect you guys to be able to do. And to do very well. So that you can move ahead in life. Start worrying about other things than these kinds of things. Okay? But these kinds of things, stats, guys, when you become a doctor, if you choose that career path, you're going to do research when you choose to become a specialist. And I think research is going to be even a part of the undergraduate's degree. The way it's so robust, I can feel it. It's going to come into undergrad. But even with us, when we did ONG, obstetrics and gynecology, in 5th year, we were forced into doing some research. Of course, you can see that we were just helping the postgraduate students in a way to collect data and to somewhat give an indication of what's going on, because they were the ones that are going to be the beneficiaries of that crude work we did. But we actually did, because we were doing what we called practice of medicine, which included what we called EBM, evidence-based medicine. So as part of family medicine, so to speak, we needed to provide evidence for the work we do. And evidence comes from our actions more than the rubbish that you read people writing. Because sometimes they make up for certain truths that they cannot admit to. And sometimes they fail to answer certain questions, but they pretend they did, so that everything looks nice, so that they can sell the products if they are affiliated to some companies that sell things. So be very careful of a research of someone who's affiliated with some companies that sell products, because they are forced to somewhat showcase that product in the good light and try to diminish the light of the things that are already working perhaps cheaper, so that they can make money. Later on you realize it's rubbish. There was one that was speaking about the balanced solution against Voluvan. That Voluvan causes kidney dysfunction, so don't give it for resuscitation when somebody has a low blood pressure. Where? And everybody believed, but I was like, this is nonsense, man. And they were like, who are you? I was an intern at the time this was said, so they made me look like I'm ridiculous and I'm stupid. Okay, all right. Fine, at that moment, I lost the battle, because guess what? A lot of people believe the rubbish that's floating around, even when it's absolute garbage, just because they haven't noticed. They'll be like, who are you to disagree with the big ones? And I'm like, who am I not to see if I have a brain between my eyes? Do I need other people's brains? Okay, maybe to some extent, but not entirely. Anyway, a few years later, it came out that that was ridiculous. Now I was a winner. But of course, those ones who opposed me were not there to see me gloat on winning. All I'm trying to say, folks, certain things like stats you're going to need, but there will be a lot of lies surrounding that. So be very careful. I even question the quality of the PhDs that the country awards currently from our universities. I don't see any change. Remember, a master's degree is heavily on research. So your thesis for your master's needs to change something, right? Or at least it has to answer something. But remember, it always somewhat works around what already exists, but perhaps uncovers it a bit more. But PhD has to bring something from the ground to light. You can't be describing another person's work in a PhD. It's de novo, start to finish. It's a prototype type of research. Now, those kinds of researches, when last have you seen them or heard about them? I don't know, because there's a lot of PhDs I see being awarded in the country. Maybe I'm jealous because I don't even hold masters. But about honors, I don't have anything except my just undergraduate degree. Okay, MBCHP. That's all I have, guys. I don't have a master's degree in anything, so I'm useless in this regard. Maybe I'm angry because of that. I don't know, because actually, guys, I'm not any younger. So I should be having these degrees under my belt, but I don't, because I live in a country called South Africa, where opportunities, sometimes you just question the distribution. Not to say distributed, just how they allocate this to individuals. In fact, it should not even be a question of allocation. We don't have enough universities, number one. We need more universities. And so that it matches the population, because the population has increased, folks. Now, even matriculants are smarter now. They are all getting distinctions from university. We hardly, you would be lucky if you score a distinction or two in your university and you finally graduate with those distinctions. A cum laude was a rarity back in the days. You would definitely be some special individual to get there. Even hard work would not get you there. It would just make you make it, but not get there. But nowadays, you guys are too smart technology, the way we teach, online resources, of course, we can only ask questions around same concepts. So it's easy now to crack things. Even people needed to know how to read textbooks, because many of you don't know how to read textbooks. If we were to rely on that same old system where there wasn't much online and everything had to be coming from the textbook, from the student, if you didn't know how to read the textbook, you would not make it. I don't care how often you read, how often you go to the library, whatever you do, if you don't know how to read a textbook, you are useless. In fact, this is what is lacking nowadays. People don't know how to read textbooks. They just listen to people. I see a lot of you guys. Sometimes I worry about you folks. You know, I look at these online platforms. I mean, guys, why would you watch a video showing you how to prove theorems? Like for grade 11 and 12 theorems. Why would you watch such a video? Sometimes I did that too. I did some videos and I saw you guys watching it. The reason why I'm saying it is because you watched my videos where I was proving a theorem and then showing its applications. Maybe I would say the part that you should perhaps look at is the applications. Okay, I understand that part. But I don't understand the theorem part. And anyone who posts theorems, I see videos being watched and I'm like, these students are useless. Because folks, what do you go to school for if you are going to be taught theorems more than once? Because they are there in your textbooks and you carry them around, but you still watch somebody else prove a theorem the same way that it is proven in the textbook. Really? Alright guys, stop this nonsense, man. You know, just quit the nonsense. Anyway, I don't know what I was talking about before I got to that, but it worries me honestly that you guys, you are too dependent on online resources to a point where you're missing the point and you're actually becoming low quality fruits. Because remember, you are fruits, guys, of our education system. But you're going to be low quality type of fruits that don't get exported anyway, because you are of low quality, right? So you are to be fed to the pigs, not to be fed to the kings. Nah. Yeah, so please guys, know how to read textbooks, because I only got this knowledge I have and I'm sharing with you by knowing how to read textbooks. I never relied on studying notes from some lecturer or scope or slides. I took my textbooks at university, thick as they were. I read those things. If I was writing on 8 chapters, I would make sure I have read all those chapters. I would never go to that exam without finishing. Of course, not so much retention, of course, because of time. Unfortunately, you just can't. But here's the thing. I read the course guidelines that we used to be given before we start any course. If we're doing human physiology on this particular section that covers these chapters, there would always be objectives of that course, right? I would read those. This is how you learn how to read your textbook. Then from those objectives, what are you going to do? Read the definitions. That's the start, okay? Same as you would say, a course guideline here would be those examination guidelines. But remember, it's not the only thing you need to read. I see a lot of mistakes being said to you guys. You don't just read those and reproduce them. No, use them as a guide as to how much you need to know from the textbook. And I hate anyone who says, no, we don't take our definitions from the textbooks. We take our definitions from the exam. God, people, where do you come from and why are you even teaching? Because you can easily just refer students to those nonsensical guidelines. I would call them nonsensical, not because they're nonsensical, because I'm angry at people who say those things like they are the Bible of life. No, they are guides, people. Guides. It's what you would do if you have nothing better. You get me? That's like standard stuff. It's not the only thing you would do. It's not the limit. It's the lower limit of what is acceptable. Those are the guidelines. But rules, it's another thing. Rules is what you would not do without. You don't bend the rules. You follow them. If you don't, you lose out. But again, rules is a strategy to keep certain things within certain limits. It's not to say they could not be moved. You know, the goalposts could be moved further back or further forward or remain wherever they are. It doesn't matter. Anyway, guys, what I'm trying to say is, bente bye-bye. Antanga bye-bye. Maske start at the last minute, ne? Yeah. So what I'm trying to say, guys, you need to know how to read. Because you don't know how to read, right? 2, you don't know how to study, because I see you guys listening to tips on how to study. Then everyone is saying the same thing, but you keep watching it anyway. And I'm worried, because why are you even at Matric if you don't know how to study? You don't know how to strategize. This is ridiculous, people. Look, we consume a lot of rubbish, honestly speaking. Because, folks, really, there's no study method that is superior. It just depends on the individual, on how they can use what they have. Stop wasting time adopting ridiculous techniques that don't even matter, just because you're so desperate for it. Hey, guys, desperation is a disaster. I will tell you a story about me and desperation some other time in the future. But for now, let's quit, because I'm going to make this video too long. But all I'm trying to say, guys, that desperation that is going around is making you guys fail, because most of you are actually failing. As much as those of you who pass so well, but it's still a very small proportion compared to the majority of people who fail to achieve their desired results that actually put them at a good position in life. It's because you guys are consuming garbage that is made to sound nice, and you reject good stuff that is given hardcore, because you don't like to face the truth. You like to live in a bubble. I don't know. It's like that. Anyway, guys, goodbye. Please share that question if you have. I would love to look at it nicely, so that we can see how we can share ideas on solving those questions, and also to showcase the practicality of what we've been preaching throughout this channel since its inception until now, because my channel is nearing its end in terms of new stuff, because I think for Matric there's nothing new I have to teach you, or that I can teach you or showcase to you. It's more like a repeat, and I hate to repeat myself, but I realize that sometimes I don't say what I mean without noticing it. Hence I kind of became patient with repeating myself so from 2021 until now. Let's see, 21, 22, 23, 24. Yeah, this is 5 years. Usually a curriculum expires at 5 years, right? So I think my curriculum it automatically expired at the end of this year. Because my channel was around July when I started it, or August, somewhere there. So by July, August, it's going to be reaching full 5 years. I think I have nothing more to share with you guys for your level of study. You just have to find a way. Of course, I will not delete the channel. I'll probably leave it there for you to see. But I don't think I have any interest in repeating myself and competing with babies, because there's too many good babies now that are coming through. And those ones must take the center stage and showcase their talent. Because remember, their talent is a constellation of my talent and many others who are doing this with me. And the special talents that those people are coming up now are going to bring forward. So let's give them a chance to advance our nation. We can't hold it in the past. I am the past, because what I know and have been doing is in the past, right? So maybe we need to see some new skills, including some technological stuff, you know? Yeah, so I need to bow out at some point. I think I've served my purpose. So yeah, sooner or later, you may not see me, but you will see the channel, hopefully. But even if you don't see the channel, because I think YouTube is capping my channel. That's the only explanation I can say, because there's a mismatch of things here, which is not a big deal for me. But I'm worried when stuff that can transform people is not robustly given, like it doesn't trend. And shit that doesn't help, excuse the profanity, but it's not profanity, it's just insolence. Excuse the insolence. The shit that is garbage, that is destructive in nature, is trending like God knows what. You know, people are going to talk about how McG, talked rubbish about Mini. And now it's everywhere. Even the courts are starting to entertain this nonsense. Politicians. Like, people, would you really assassinate or hold the nation to a standstill for just one individual? But there's individuals suffering here. We need good tablets, like Samsung tablets, not these rubbish tablets they give to school children. Those things overheat when you teach them, and then sometimes I don't blame these kids when I'm giving them a lesson and then they disappear within the lesson because their tablets overheat, because they're using the school tablets. Because they buy these cheap things, but for billions. Can you imagine this country, man? It's wrong. They like to buy cheap things and chow the rest of the money. No, man. Buy quality. Just eat a little. Whatever is left over, even if it's 50,000, share it amongst yourself. Maybe it's going to be 500 each. It's okay. Buy a drink or a meal at a restaurant. But you cannot go and stomach millions, man, and give kids garbage. Anyway, I don't know where I was. I didn't able to I get tsebe le nna gore jwale ke reng e re ke tloele he empa ne ke le jwetsa he taba ya gore e seng khale ke tlo nyamella hobaneng dintho tse bohlokwa jwale di hlahela ka honna ka mona ke na le mosebetsi o moholo jwale on shebileng gore ke o etse ke o qete ebile ka katleho ha ke batla o qeta ntho fela ke fail ke batla e qeta ka katleho holo haholo wangu kudu entshi haiba wankwa kampa wankwishisha ya tsona tseo ke tsona jwale ke a jwetsa he bana beso hore nna ke fihletse mo ke nahana hore ke qetile wa ka mosebetsi baneng ke a bona hore ba bangata jwale ba hlahellang ba tsebang ho etsa mosebetsi ona ebile ba o etsa betere ho feta nna ho tsho hore the illumination has been done. So siyanomeka umlilo, right? Yeah, siyanomeka. Andazi nge-English ukuthwani ke ngo. Ukunomeka is to do what? Yeah, yona leyo guys, we're passing on the baton as we say it. So we need to pass on the baton. We don't need to grow old in this thing. Our job is just to showcase it. Once you catch the fire, we let the fire burn, right? We can't keep lighting here and they will end up confusing the fire. The fire has to scorch where it has to scorch. It has to spare where it has to spare. But if we put fire everywhere, we're going to burn even good things that we don't need to burn, right? Right. So in the event you don't hear or see from me, just know, guys, it's done. But so far, nothing is confirmed yet, but I am working towards something. Even before the confirmation, I must be ready. Remember, there's something we call luck, but technically a friend of mine said to me, luck is when opportunity meets preparedness. Because if you meet an opportunity and you're not prepared, you're going to lose out despite coming across that opportunity. So that's not luck. That's a misfortune. When you get an opportunity and you're not ready for it. So even though I'm still looking to score some big opportunity, I need to stay prepared for it. Even if I don't get it, I will stay prepared anyway. It doesn't hurt to stay prepared, but it hurts to lose out. So that is the thing. Okay guys, goodbye. Before I talk too much, of course, this talk is just for you and I, those of you who have the patience to listen, but those who did not should have ended where the video of calculations ended. Otherwise, guys, I'll see you some other time if that will exist. Goodbye.